Hello, everybody. How are you? Hey, good afternoon, all. Everybody, a very good afternoon to all of you, my dear students. And in session low, we will be talking about your thermal properties of matter. Everybody, how is the Josh? Give me the attendance, Ukasari. Type in the comment box. Am I audible? Am I visible? Ukasari Shippendi Andari. Is everything clear now? Everything clear? Everything clear? Not clear. Hi, good afternoon. Sir, so shall we start the session? All of you, everybody ready? Ready, not ready. Hi, good afternoon. Sir, so we'll simply go with our flow. Okay? Good afternoon. Hi. Good. So, Iroju, we have our thermal physics and heat. ఎక్కడ నుంచి చూడండి మీకు 3 చాప్టర్స్ ఉన్నాయి. The first chapter is your thermal properties of matter లేదా thermal properties of solids. Okay, thermal properties. The next that you have is your KTG, kinetic theory of gases, and దాని తర్వాత you have your thermodynamics. I'll simply say that these 3 chapters are left, okay? And except these, your modern physics is left. ఇదే కదా? Yes. Except this, your modern physics is left. Andariki. Modern physics and at least expect at least 20 to 30 marks in your exam. At least 20 to 30 marks. Ide kada? Yes. At least 20 to 30 marks you can easily expect all of you in your examinations. And all these 20 to 30 marks will be done on your 1st of February, Sunday, all of you. This Sunday, until day after tomorrow, kada? Yes, Sunday, your 1st of February will be the day we will be covering your entire modern physics. Now, the only chapters that are left, later the headache for me, are your KTG and your thermodynamics. Because these 2 chapters, they are there in the February month. Okay? Migita, all of your syllabus has been completed. Yes, there are some small topics. We'll take it. Okay? We'll take it. Before beginning the lecture, I want to let you know about the offline offer. For the 77th Republic Day, you do have a scholarship of 77% in your offline centers. Okay, so interested students, you can visit your nearby Vedantu centers to avail this scholarship. Okay, you can book a visit and then you can use the offer. It's only valid till 31st of January. Okay, last day of this offer, 77% scholarship, is till 31st of January. Sir. So, my dear students, with that being said, we will start with your thermal properties of matter. Yes. This chapter, let me just give you what we will be discussing. Thermal properties of matter. Not in the center, sir. It's not in the center either. Let us take it in the center itself. Good. The topics that we will be discussing, Andariki. Your temperature scales, we'll talk something about your heat conduction. Okay. Right. Then we will talk about calorimetry. Okay. Right. Then we will talk about your heat convection. Okay. Right. and then we'll talk about your heat radiation. These are the topics. Kani, there are okay, bioclass is there. Bioclass is there. It is not over, right? Yeah, bioclass is there, right? Hi, hi, hi. Hi. Your bioclass is over, not over. It's there, it's there, it's there. It is there. It is. Okay, 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 okay. Okay. Your bioclass is there. Sorry. What to do, Ra? Aim cheyali. Till your bioclass gets over. No problem, right? 10-15 minutes lag will be there, okay? 10-15 minutes. Might be your class will be over by 10 to 15 minutes. Okay. Yes. Now one topic is left. How long it will take for your bio class to get completed? Cheppandi. For yours. Hi, hi, hi. Good afternoon, good afternoon, good afternoon, everybody. Sorry. We will start, okay? We'll take some basic concepts till that time. Just one. Let us talk about your temperature scale, okay? Leda, give me 5 minutes, okay? I'll be back in 5 minutes, all of you. Okay, I will be back in 5 minutes. Sorry. So let us start. Okay? So let us talk about your temperature scales. Choose one. You have 3-4 types of temperature scales. We'll just be discussing about your degree Celsius, your Kelvin, and your Fahrenheit. Okay. So first you have okay. So we have your temperature scales. Okay. Number one. You have degree Celsius scale. Okay. Then you have the spelling cheppandi. Okay, sorry. This is the spelling. I'm weak at spellings. Okay. Good, good. Lastly, you have Kelvin scale. Okay. How to do the conversions? There is a PYQ. There is a PYQ asked only on the conversion of the number scale itself. Okay, there is a PYQ asked. So how do you do the conversion? Okay? You try to understand. You only have to remember the numbers. Numbers and entira. When you have water, you have ice point of water and you have boiling point of water. Ide kada? Spelling correct kada? Yes, correct. Spelling is correct. Right. Sorry. So you remember, okay, you remember about 2 points. Number 1 is your ice point. And number 2 is your boiling point, లేదా vapor point. Okay, vapor point. You talk about your vapor point. ఇప్పుడు ఒకసారి this information is there, మీకు values గుర్తుండాలి. అదే, it is the most important thing. Okay, try to understand. Your temperature scale, your ice point and your vapor point, right? If it's a degree Celsius కోసం your ice point is 0 degrees Celsius. And your vapor point is 100 degrees Celsius. ఇదే కదా? Yes. What about your Fahrenheit? Do you know the values? Do you know the values of ice point for Fahrenheit? Your Fahrenheit has the ice point of. What about the vapor point, sir? Your vapor point is at 212 degree Fahrenheit. What about your Kelvin scale, What about your Kelvin scale? Cheppandi. Kelvin scale, your ice point is 273 Kelvin and your vapor point is 373 Kelvin. Finished. If you know this table, ade. Okay. DJ Tillu. What your name is? Sir. Anyways. Right? So these are the values. Okay, you will have to remember all this. Anyways. So what to do, sir? For any scale. Idigo. Remember this property. For any scale. I'm giving you the shortcut. No need to remember the formulas and all. Okay, no need to remember the formulas and all. For any scale, for any scale, remember the formula that I'm giving right now. Okay, and if you have x value and x degree Celsius, x Kelvin, x Fahrenheit. Yes. Minus the highest point divided by vapor point minus the ice point is equals to constant. This is constant. That means you can simply say x degree Celsius minus ice point and 0 kada, divided by vapor point in degree Celsius. Cheppandi vapor point in degree Celsius is 100 degrees Celsius minus 0 ice point. Should be equals to degree Fahrenheit. Cheppandi ra okasari. Your y degree Fahrenheit ide kada? Yes, y degree Fahrenheit minus ice point cheppandi okasari 32 divided by, you can say vapor point is 212 minus 32. Very good. Understanding? Okay, right. So that means we can simply say, sir, x degree Celsius divided by 100 should be equals to y degree Fahrenheit minus 32 divided by 212 minus 32. Understand? 212 minus 32 anta 180. 180 kada? Yes, 180. You send it that side and then simply get, sir, your x degree Celsius is equals to 100 divided by 180 multiplied by y degree Fahrenheit minus 32. 0 gone. 5, 9. You can simply say, sir, x degree Celsius is equals to pi upon 9 times of y degree Fahrenheit minus 32. This is the formula. If you want to remember this, you remember this. This is the key. This is the biggest key to remember any formula. Okay, any formula. Try to understand. So let's take a PYQ. Actually, that's the PYQ. To be honest, I think so. Question this one. The question is, on a new scale of temperature, which is linear, okay? Which is linear. This is also important. And called W scale, okay? And called the freezing and boiling points of water are the freezing tank point, yes, the freezing and boiling point. Water, they are 39. I'm sorry. It should be 39 degree W and 239 degree W. Respectively. What will be the temperature on a new scale for 39 degrees Celsius? Your 39 degrees Celsius a day, it is your degree Celsius scale. Option A, 117 degree W. Option B, 78 degree W. Option C, 139 degree W. And option D, it is 200 degree W. Formula ante ide. This is the key formula. Master key, okay? For every formula, okay. Cheppandi andari. So this is a Question. ఇలా చేయాలి సార్. You simply do one thing. What? For any scale, your x minus ice point divided by vapor point minus ice point should be equals to constant. Constant and telsa. This for your W scale must be equals to same formula for your Celsius scale. Ade ante it becomes y Celsius. Hey, I'll not write Celsius here. Y minus ice point divided by vapor point minus ice point. For Celsius now. This is for W, this is for Celsius. ఈ క్వశ్చన్ కోసం మాట్లాడుతున్నాం, చూసుకోండి అందరికి. Substitute. Your ice point is 39 degree W. Your vapor point is 239 degree W. Substitute చేసుకోండి ఒకసారి. So your x minus 39 divided by 239 minus 39 should be equals to your degree Celsius kada. Yes. Y degree Celsius minus ice point is 0 sir. Divided by vapor point 100 minus ice point మళ్ళీ ఒకసారి 0. 239 minus 39 అంటే 200. Yes. Okay. Yes. 239 minus 39 అంటే denominator చూసుకోండి అందరికి. So you can simply say that x minus 39 divided by 200 equals to y divided by 100. 0 gone. Your y is equals to y degree Celsius kada. Yes. Y degree Celsius should be equals to x w ra. It is in w kada. Yes. ఈ మొత్తం అంటే ఈ w. So your x w minus 39 upon 2. What you can say, sir? Sir, your y degree Celsius is x minus 39 upon 2 kada. Yes, substitute చేసుకోండి ఒక్కసారి. Your degree value is given as 39 degrees Celsius. Substitute everything substitute it. చెప్పండి. You can simply say, sir, x minus 39 divided by 2 is equals to y degree Celsius. ఇదే కదా, నాకు degree w కావాలిరా. So send everything that say. Let us substitute. ఇదే, it's all up to you. So you can simply say, sir, x degree w is equals to 2 multiplied by y degree Celsius. ఇదే minus 39 కదా, it becomes plus 39. Finished. అంటే 2 into y degree ఎంత ఇచ్చారు క్వశ్చన్లు? 39 కదా, సబ్స్టిట్యూట్ చేసుకోండి. So it is 39 plus 39. If you are smart, take 39 common and multiply it with 3. Oh my goodness. 7, 3 3s are 8. Perfect. Option there. Option A is there. Yeah, understand? Just this type of questions, they are usually asked in your JEE, okay? JEE. And what happens is, okasari, this is a very basic question actually. Chusaru kada, the simple formula has been used. Kani, when you are in your examination hall, your major target is to achieve simple topics such as your semiconductors, like the modern physics, or else if you are attending your Newton's laws of motion, something like that. Your eyes will be searching only for those questions, ra. And in that race, you will lose this question. Because it is actually a very easy question. Try to understand. Okay? So take the hey, I have a mixture, okay? When it comes to teaching to your NEET students, the easier classes unte, I simply use adopt, I adopt comedy. But when I'm teaching for JEE, Olympiads, I don't use comedy. I simply go and I try to. Endukante, you understand, it depends upon the mentality of students. Okay? In NEET, most of the students fear physics. Physics ante chala difficult. Kabatti, to keep entertainment and as well as the portion in syllabus, I use this humorous technique. Right. When it comes to JEE students, they don't need something like that. Right? They are already there into the depth of the physics. So I simply start and I'll go. Okay. ఇప్పుడు చూడండి. Hey, do we have one more PYQ? Do we have one more? Yes, it's there. It is there. Okay, it is there. Not there, huh? Sir, you keep it in mind only, okay? You only remember these formulas because there is no other PI. This was the only one. Great. So your thermal scales completed, Kida? Good afternoon, good afternoon, good afternoon, everybody. Yes. So if you want to see the advanced classes, right, you can go and visit my channel, but not there. Yeah, no problem, no problem. It's all right, it's all right. చూసుకోండి ఇప్పుడు we are moving to the mainstream of the chapter. Okay? The mainstream of the chapter is your thermal expansion. Okay. Yes. 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 So your thermal expansion అంటే ఏంటిరా? If you have a metal చూసుకోండి. It is mostly useful for metals. అంటే you heat the metals, they will expand. అదే simply. Metals అంటే conductors of heat. Sir, we want to expand this pencil, so you burn it. It will not. Simply does not, okay? Hi. Now, when you talk about your thermal expansion, you have the metallic objects, kada? Yes. So when you have a metallic object, if at all this is your metallic rod, chudandi. If this is your metallic rod, you heat it. What you are doing is you are heating this rod. What will happen, sir? The atoms, they start vibrating. Okay? The atoms, they start vibrating. Yes. As soon as they are vibrating, you try to understand, okay? As soon as they are vibrating, until the region has been increased, the region of the vibrations of the atoms. So based on the conditions, we have three type of expansion, okay? Number one, your linear expansion. Okay, yes, your linear expansion. Number two, your aerial expansion. And number three is your volumetric, లేదా volume expansion. Let us see all one by one. When you have your first case అంటే ఏంటిరా? Case number one. Not properly. Is it buffering, all of you? Clear, everybody? I hope it's clear now. Clear? Yes. Okay, okay. Great. So there are some problems, right? Just go. Now, first let us talk about your linear expansion. Linear expansion, you have a rod, okay? A metallic rod. A metallic rod of length L. Andariki. Length of this rod ante capital. You are heating it. Heat chesina tarvata, the length of this rod increases. Ade kada? Yes. So after some time, what you will see is this length of the rod, it increases to a new value. Ante idigo extra length kada? Yes. This extra length delta. Try to understand. Now I am only interested about this extra length kada? Yes. So this extra length delta L, it is directly proportional to two quantities. Okay, two quantities. Number one. This extra length delta L is directly proportional to the initial length. Let us say it is L naught. Okay, L naught. Point number. It is completely observation. Experimental observations. Let us say the temperature that you have increased, and let us say here the temperature is T1. T1 temperature, the length is L naught. And the temperature here you have increased to T2. T2 temperature, you have the length as L naught plus delta L. Give me 5 minutes, all of you. Let us block this guy, okay? Let us block this. See, you are matured students, ra. Okay, grown-ups, not a class 5, 6 students kada. So you should be having some responsibility. Kuncham bajita undali ra. Okay? You have free access to internet. Your fingers are free. Comment box is free. So will you type anything you want, ra? Huh? Understanding? There should be a little sense of knowledge, at least for the students who are sincerely preparing in this channel. Okay? The future, the family responsibilities, the dreams of all the students getting the attention, commenting some vulgar words and getting the attention, kada? Yes. Sometimes I feel very pity, ra. Like sometimes I feel very bad about these students, whoever, do this abusing and all these things. And at least think of your parents, okay? At least before telling. Yeah, that's what. This chat box is meant for your doubts. Doubts and whatever I'm teaching. If you are having any confusion, sincere students who are preparing, okay? Hi. I remember you. Don't worry. I remember you. Abhi, no, I remember. But at least have the shame to speak something in front of the teacher and in front of the sincere students who are learning. This is the last time I'm telling you. Ledante, if this nonsense continues, okay, I will simply block that idiot. Ledante, I will not take the class itself, okay? Let it be. Whatever it's happening, let us happen. I don't want any sincere student loss in this all nonsense, I don't want the loss of each and every single serious student. Sir, anyways, let us continue the discussion, okay, all of you. And to be honest, try to understand, whenever a person abuses, Leda, whatever words he says, it shows you the upbringing and what his family teaches to him. You're understanding? Yes. Anyways, choose one. Sorry. I'm only concerned about the interested students. I'm only concerned about that idiot is abusing everyone here and there. Okay. Perfect. Sir. So let us continue. If at all he peeps into the chat box again, we will again block him. I don't care, okay? If it is 3 hours or 4 hours or 6 hours of lengthy class, let us do all these things, okay? But I'm not going to tolerate any abusive words in the comment section. Let me make it very clear to all of you, Andariki. Whoever wants to abuse, open WhatsApp, message yourself and abuse whatever you want to abuse, okay? But don't use this chat box. Andariki. No, and I'm not going to tolerate even a single statement that is not related to our course. Okay? Right. If you want to attend, attend. If you don't want to attend, leave it. Even if there is no student in my life, I will take the class. No problem in that. Okay? Sorry. There are a lot of stressful conditions, Ra. These idiots, they do not have the brains at all. For all the sincere students, okay? For everyone. Now, there are a lot of students who want to prepare very sincerely. Okay? Ignore such comments. Ignore such idiots. Even in future, if some such sort of idiots come into the class, peep into the classroom, you see their words and you understand that it is their mentality that has been transferred from their parents. Okay? Sir. Okay, so let us talk about your increment in the length here. Yes, delta L. So this delta L or the extra length, it is directly proportional to the initial length L0. And at the same time, this delta L, it is also directly proportional to the change in the temperature. There you go. These are the conditions. Okay, right. When you club them together, ante you will have the value of delta L is directly proportional to L naught into delta T. Ide kada? Delta T ante change in the temperature. Simply. Delta T ante simply change in the temperature. Ippudu what you will do is you will simply replace this directly proportionality symbol ra. Idigo. You replace it with equal to sign and some constant of proportionality. Yes, so you can simply say that your delta L is equals to some alpha constant of proportionality, alpha times of L naught into delta T. This is the formula. Alpha ante enti ra? Your alpha is coefficient of linear expansion. Yes. Your alpha is coefficient of linear expansion. So this is the value of delta L. Sir, what is delta L, sir? You try to understand. Okay? I'll tell you something. Choose this total length L unte this delta L kavali kada. So can I simply say, sir, your delta L is nothing but L minus L naught. Ide kada? Yes. Your delta L is equals to L minus L naught. Substitute. Delta L ante sir, your L minus L naught is equals to L naught alpha delta T. Understand? Andariki. Okay, so your L value becomes L naught plus L naught alpha delta T. Take L naught common ra. You are left with 1 plus alpha delta T. This is the final length of the rod. Andariki. Ardhavindi? Yes. Correct. I know ra. Okay? I know 99% students, they are preparing, they are very sincere. I know it. But sometimes that happens. Kada? Hey, here, try to understand. Coefficient of linear expansion ante alpha. The same thing, the same condition we will apply for your areal expansion also. Areal expansion ante enti, sir? If you have the areal figures ante disk, square, rectangle, triangle, all of them, they are areal expansions. Yes. So if you have a disk, student, so if this is your disk, this is your disk. Finished. Not like this. Okay. Same condition. And in case we are talking about length, kada? Yes, you will simply say that L equals to L naught into 1 plus alpha delta T. You will simply say that your area ante pi r square kada? Yes, your area is equals to A naught into 1 plus beta delta T. Conditions చూసుకోండి రా అందరికి. Alpha ante coefficient of linear expansion. ఇదే కదా? Yes. Okay, we can't do anything for that. If your ads are there, it's not in my hands, kada. So if it's my hands, I'll definitely do something. And it's not in my hands. So please adjust for now. You will simply say that your area is equals to A naught into 1 plus beta delta T, kada. Yes, very good. What is the value of beta? What is the value of beta? Beta ante, this is simply the coefficient of areal expansion. This is the value of beta. Okay, right. Alpha ante coefficient of linear expansion. Beta ante coefficient of areal expansion. Ide kada? Yes. So how will you write, Ray? How will you write? I will tell you the shortcut. Okay, shortcut ante enti ra? You imagine something like this. If you are hitting any object, it's a 2D object, it's 1D object, లేదా it's 3D object, or else it is the object, superficial expansion, right? లేదా it is the object with a cavity అంటే ఏంటి సార్? hole. Yes, you do the single thing, try to zoom it out. This is how it expands. You are understanding? Expansion happens in such a way, try to understand, all of you. This is how the expansion works. Until you zoom it out, finished. Are you just understanding? You just zoom it out. You zoom it. Your expansion is completed. Ide kada? Yes. Correct. Now, what you will do is, you will try to understand. What about area, sir? Your area ante final area ఇదే కదా? Yes. So let us say అందరికి this is the initial situation. This is the initial situation. మీ final situation లో the things are something like this. Try to visualize. Okay? Hey. Finished. ఇదే కదా? Yes. Okay. Now let us say the radius over here is R2. Here the radius is R. And R1. Here the radius is R2. Increased కదా? Yes, the radius has been increased. అంటే what will you write the formula రా? ఈ ఫార్ములాలో your area అంటే ఫైనల్ ఏరియా అంటే pi into R2 square should be equals to pi into R1 square 1 plus beta into delta t. ఇదిగో your pi gone. Understanding? Right. So that means, sir, your R2 square is equals to your R1 square into 1 plus beta into delta t. Lastly, we will talk about your volume expansion. Andariki. Let us talk something about your volume expansion. ఇదే కదా? Yes. Volume expansion లో you have 3D objects కదా? Cube, solid sphere, hollow sphere, లేదంటే all the 3D objects they do come under your volumetric expansions లేదా volume expansions. చూసుకోండి. Now the same thing works here also. What is the same thing రా? This is your cube. If this is your cube, అందరికి చెప్పండి రా. Hey, tell me all of you. If this is your cube, let us say side length is A. Okay? Yes. Dual expansion, volume expansion. If the side length over here is A. This is also A. Ide kada? Yes. When you heat it, the cube expands. Expansion kada? Yes. The cube expands until the length will get expanded. Expanded ante zoom it out. Like this. You are understanding? Expansion is happening. What will you say here? Same property. Same property and enti, sir. Last case we talked about your area kada? Area. This case we will be telling about the volume. Finished. The volume is equals to V0 into 1 plus the only change is gamma. Gamma into delta T. Idigo. What is this gamma, sir? Our gamma is coefficient of volume expansion. లేదా volumetric expansion. ఇదే కదా? Yes. Coefficient of volume expansion. Finished. Okay. Hey, he has been blocked kada? Sorry. So gamma is volume coefficient of volume expansion kada? Yes. Now what we will be doing is, hey, if anybody comes, okay, if anybody is coming, you tell me only, okay, you tell me. Here is me, there is you. All of us will. Sorry, let's compare, okay, compare. Chuskondi. Your linear expansion, this is your areal expansion, and this is your volume expansion. Ide kada? Linear expansion, areal expansion, volume expansion. Who is it? పేరు చెప్పండి ఒక్కసారి. Who is bothering you? Okay. Linear expansion కోసం you have the coefficients kada? Yes. Your coefficient for linear expansion is alpha. Andariki. Your areal expansion coefficient is beta. And the volume coefficient expansion is gamma. Here you go. These are the three terminologies. Now, what you do now here is, let us try to link a relationship between these three. Okay? Let us try to link a relationship. That means for solids, right? Here you go. For solids, you can simply say, sir, your gamma is equals to 3 alpha, and your beta is equals to 2 alpha. Here you go. You're understanding? This is a relationship. Okay? Yes. Hi. Your gamma is 3 alpha, your beta is 2 alpha. Ide kada? Yes. You can also make any link. Link and the sir. Your gamma upon beta is equals to 3 upon 2. And your gamma is equals to 3 by 2 beta. These are the relationship between the coefficients of expansion. Okay? Right. Try to understand. Now, let us move a little forward. What is the conditions here? The condition and let us talk about the object with cavities. Cavities, the objects with cavities. How will you define the cavities, sir? Depende. Okay. Cavities and dainty. If at all you have a spherical surface, something like this, try to visualize. Just this is a cavity. Hey, sphere. Yes. So when you talk about a cavity, it is simply the empty space. The empty space. Okay, the empty space. Try to visualize. I'm unable to tell you the cavity. Okay. Let us do something like this. Let us take a black color and make it dark. Oh, nice. This is a cavity, yes. Yes. So this is a cavity. Let us talk about the radius. Let us say this is the radius of the cavity R. Now, when you are expanding, when you are heating it, what's happening? I've told you to remember the shortcut, and it will simply expand and zoom out. Understanding? And your cavity is also expanding, exposing the secrets. Can I try to understand? Okay? Now, what can you write about this R is, you can simply say, sir, the equation for R is equals to, volumetric expansion, kada? Yes. Okay, so you will simply say, sir, your volume final is equals to initial volume into 1 plus gamma into delta T. Volume final into entira 4 by 3 pi into R cube should be equals to 4 by 3 pi into R naught cube into 1 plus gamma value entira. Volumetric expansion unte gamma is 3 alpha kada? Yes. Substitute 3 alpha delta T. So from here 4 by 3 pi gone. What you are left with is your R cube equals to your R naught cube into 1 plus 3 alpha delta T. Finished. Okay. Yes. Let us take a question. All of you, okay? Let us take a question. And then let us see how many of you can answer it. Chapandira. So if you have hey, try to understand. Okay, it's a semicircular ring, ring kada? Yes, it is a semicircular ring. It is a semicircular ring. Let us say 2 points on this ring. First point is your point A. Second point ante ide me point B kada. ఇప్పుడు జాయిన్ చేసుకోండి రా, ఈ పాయింట్స్ ని జాయిన్ చేసుకోండి ఒకసారి. సో యూ సింప్లీ సే సార్ దిస్ లెంత్ రా L కదా. Correct. Can you tell me if I'm hitting it right? If I'm hitting it, alpha ante coefficient of linear expansion. Cheppandi. What will be the final distance between points A and B? Final distance between point A and B ante, let us say initial distance is L naught ra. Me final distance L is equals to your L naught andariki, your L naught into 1 plus alpha delta T. Idigo. You can say this way also ra. And this will be known as the thermal expansion of the bounded points. Bounded points kada? They're bounded. Yes. Thermal expansion of your bounded points. Bounded points into the figure. Ippudu you're done with it. We'll talk something about your apparent expansion. Apparent expansion. There, not there. What is the time? 3:30. Let us take a break at 4 p.m. Okay? Break at 4 p.m. Andariki. Because we have to. Yes, 4 p.m. we will take a break. Okay. So, let us talk something about pendulum. What is the time period of pendulum, Ra? What is the time period of pendulum? So your time period, and if you have a pendulum, metallic pendulum, okay? This is your pendulum, length is L. Your time period is equals to 2 pi root of L upon G. Choose one. Heating it. When you are heating it, the length is increasing. Increasing and expansion. Expansion and you will have the formula. What formula, Ra? If your initial length is L naught, initial length L naught unte, your final length L is equals to your L naught into 1 plus alpha delta T. Substitute cheskoni ra okasari. Your T is equals to 2 pi into root of L ante your L naught into 1 plus alpha delta T. Divided by your acceleration due to gravity is G. Ide kada? Yes. Sorry. So can I do some simplifications, Ra? Can I do some simplifications? Cheppandi. You simply say that your T is equals to 2 pi root of L upon G multiplied by root of 1 plus alpha delta T. It's 1 plus alpha delta T. Now simplify it. More. T is equals to 2 pi root of L upon G multiplied by 1 plus alpha delta T to the power half. In mathematics, you have something known as your binomial theorem. Binomial theorem. Yes. I is to steam. No. We are talking about your specific heats, kada? Melting and all these things. It's not completed yet. Sorry. Anyways, try to understand. So, your 1 plus x, your 1 plus x to the power n can be approximated as 1 plus n into x. Ide kada? Choose 1 plus x to the power n. And 1 plus n into x. That means 1 plus n value is half. Alpha delta T. Ide kada? Yes. So can I say this all can be simplified like this? And your time period nu లేదా T dash is equals to చూసుకోండి. This is the original time period కదా? Yes. TO multiplied by 1 plus half into alpha delta T. What is alpha, sir? Your alpha is the coefficient of linear expansion. Ide kada? Yes. I've wasted a lot of time, Ra. I wanted to tell you more things. Kani, because of that extra time waste, we'll have to skip something. Sorry. Ippudu, let us talk something about your expansion of bimetallic strips. It is completely about expansions ra. Chuskondi. We talked about your linear expansion, areal expansion, volumetric expansion. Then tarvata we talked about the cavities, bounded points, and tarvata we talking about your time period of pendulum. And ippudu we'll talk about expansion of bimetallic strips. Expansion of bimetallic strips. ఇదే కదా? Yes. Sir, what do you mean by bimetallic strips, Ra? Can anyone of you tell me? What do you mean by bimetallic strips? You have two strips, eh? Two strips. Yes, sir. Hey, something like this. Try to visualize. Physics and visualization. Only visualization. So let us say these are two different strips, okay? Strips ante like this, చూసుకోండి. First strip, this is my first strip, and this over here, ide na second strip. Ante kada? Yes. The best example will be your two different materials, లేదా copper and brass తీసుకోండి, okay? Copper and brass, లేదా aluminium and copper, లేదా brass and aluminium, all these things you can take it. ఇప్పుడు ఏం చేయాలంటే you heat it. అందరికి హీట్ చేసుకోండి. When you are heating it, the rods will expand కదా. మొదటిగా let us take some more parameters రా. Parameters అంటే ఏంటి సార్? Let us say this thickness is T1, thickness. Here the thickness is T2. What about the length, sir? Sir, initial length is L0. Okay. Yes. Two strips made of different materials. Right. Perfect. The metal which has more value bend on the convex side of the heat. Ade. And these two metals are not same, ra. One is more sensitive to heat, one is less sensitive to heat. Ide kada? More sensitive unte it will elongate more, and less sensitive unte it will elongate less. Kani they are joined ante they are very tightly joined with one another. They cannot separate. Ide kada? Yes. So koncham samayam tarvata what happens is the shape will take a convex side, ra, something like this. Chuskondi. So after some time the shape will look something like this. Ide kada? Yes, sir. This is the shape. And it has two strips only. This is the first strip, this is your second strip. Ide kada? Yes. The first strip ante like this. It has elongated more. Chuskondi. More is convex side lo untundi. For the second strip, it has not elongated more. It has elongated less only. It's the arc of the circle, Andri. Arc of the circle. It must be center also, right? So there should also be a center, Andri. So center will be somewhere here. This is the center. Ide kada? Yes. Thickness చెప్పండి ఒక్కసారి. Thicknesses are the same, ra. Thicknesses అంటే ఏంటి sir? This thickness is T1, this thickness is T2. ఇదే కదా? Anyways, so what you will say, ra? You will simply say, if your radius is R, if R is the radius, circular path kada? Correct? Yes, I hope so. If R is the radius, what you will say, ra? Simply, angle theta kada? Theta is same for both the strips. Idigo, చూసుకోండి. Theta is same for both these strips. Theta value ఏంటి రా? In a circle, లేదా in a sector, arc of a circle, can I simply say the length of the arc is equals to R into theta? ఎక్కడ నుంచి your theta value comes out as L upon R కదా? Yes, finished. Correct. Okay, I'm not talking about the actual values, Ra. All I want to say is the value of theta. Idigo. You remember the formula only. Your theta value is equals to L2, L20 ఏంటి రా? Let us say this value is L2, this value is L1. And L2 divided by R minus T2 should be equals to L1 divided by R minus T1. Finished. This is the property. Want to remember? What is the value of L2, sir? L2 is L0 into 1 plus alpha 2 delta T. Ide kada? What about the value of L1, sir? L1 is L0 into 1 plus alpha 1 into delta T. Idigo. Finished. Substitute చేసుకోండి. This is how you get for your bimetallic strips. ఇదే కదా? Yes. Now, let us take some PYQs if possible. Let me just check. You have some PYQs for this topic. Let us take a break. Right. Okay. Right. Hello. A let us try to understand. Okay, let us try to understand. What is the formula for L? L is equals to L naught into 1 plus alpha delta T. This is the formula. That means send it this side. Simplify. L is equals to L naught plus L naught into alpha delta T. You send L naught that side, sir. You are left with L minus L naught. L minus L naught into delta L. Change in L. Change in L. Delta L is equals to L naught into alpha into delta T. Now, two metals only. Copper and aluminium. Kada? Yes. Sir, increase in the length of copper is equals to original length of copper, alpha of copper into delta T. Similarly, you can simply say, sir, increase in length of aluminium is equals to original length of aluminium multiplied by alpha of aluminium multiplied by delta T. What do you mean by this change in the length is independent of temperature? Independent of temperature and intira. Right. What can you say if you are saying that this change is independent of temperature? Independent of temperature, sir. Independent of temperature and intira. That means whatever the value of delta L is there, whatever the value of delta T is there, it should not affect the increment in the length. Expansion. Let us do one thing. Okay, let us try to understand. So can I simply say, sir, change in length of copper minus change in length of aluminium is equals to original length of copper, alpha of copper, delta T minus, Chapandi. Can I say? Minus original length of aluminium, alpha of aluminium into delta T. You do one thing. You take delta T common. Yes, take delta T common. Delta T common is darwata. You will simply say original length of copper, alpha of copper minus original length of aluminium, alpha of aluminium. Your change in length of copper minus change in length of aluminium. If this change is equal, if this change is equal, if you simply say change in length of aluminium equals to change in length of copper, that means this value, take it that side. That means change in length of copper minus change in length of aluminium should equals to 0. Both are equal. This subtraction should be 0. And this term should also be 0. If it is 0, right side should also be 0. Right side should also be 0. And I have two cases. I have two cases. First case is your delta T is 0. Length in mottam quantity it becomes 0. Your understanding, it becomes 0. What I will use? I will say, sir, simply this equals to 0. If this is 0, whatever the value of delta T is, I don't care. 0 into delta T, whatever value, delta T, whatever value is there, 0 into whatever value becomes 0 only. This should become 0. That means your length of copper, alpha of copper, minus length of aluminium, alpha of aluminium should become 0. That means your length of copper into alpha of copper should be equals to length of aluminium into alpha of aluminium. Finished. Everything is given to you. The condition is this. So length of copper into 88 centimeter. Substitute the values. So I'll write here. Should I write here? Yes. Let us shift everything. On this side. Values cheppandi sir. Length of copper kada? Yes. Length of copper is 88 centimeter. Multiplied by alpha of copper. Inta sir. Alpha of copper is 1.7 10 to the power minus 5. 1.7 10 to the power minus 5. Ide kada? Should be equals to length of aluminium multiplied by alpha of aluminium. Okasari cheppandi, what is alpha of aluminium? 2.2 into 10 to the power minus 5. Ide kada? Yes. 2.2 into 10 to the power minus 5. Minus 5 gone. 10 to the power minus 5 gone. Ide kada? Let us do one thing. Let us remove this decimal also. So 17 into 88 equals to LA into 22. Send that side. 17 into 88 divided by 22 is equals to length of aluminium. 1/468 centimeter is your answer. So you can remember this thing also, Andariki. Correct. Correct. So you can remember if the expansion, okay, it's a very important statement, Andariki. If the expansion is independent of temperature, yes, if the expansion is independent of temperature, what will you say, Ra? You will simply say, sir, L1, hey, you say L1 alpha 1 should be equals to L2 alpha 2. Then and only then, whatever your temperature is, you will be using this condition. Student, why is it useful, Ra? Why is it useful? You try to understand. You have some devices అంటే ఏంటిరా? You have a pendulum clock. ఇదే కదా? Yes. That pendulum clock, you want to observe the time period. చూసుకోండి. For a pendulum clock, లేదా for a pendulum, you want to observe the time period. Okay? You are observing in winters. Winters low, the length is different, value is different. The same thing you are observing in summer. Summers low kuda, length is different. Okay? Length is different. And yes, week by week, plan video, it will be uploaded by tomorrow. Mostly by tomorrow, day after tomorrow. It has already been recorded. Editing, it's going in editing. Okay? So done by day after tomorrow, mostly. Okay. Yes. So when you are doing the experiment in your summers, length is different. Values are different. In winters, length is different. Values are different. So we don't want this this change in the values. You're understanding? Some errors are there. We don't want those errors. Kabatti, we'll be using the combinations of lengths. You're understanding? We'll be using the combinations of lengths in such a way that their increment is independent of the change in the temperature. Yes. One more thing, all of you, about your the offer is still valid. I just got the confirmation. Your Arjuna batch offer price is 999 rupees. And if you want it with your PYQs, the price is 1999 rupees. Okay, so if anybody who has not registered for the Arjuna batch and interested, you can avail this benefit. Okay. If you want the registration after your exam, before your exam, you see, when your NEET exam is just around 1 month, our time there will be a lot of chaos. That means you will stop eating, you will stop everything if you are sincere. You will stop everything. And you will just study. Our time, you need a perfect timetable. How many hours of study, how many questions, and all these things. I will upload, don't worry. Okay, I'm there. Kani, me Arjuna batch, you have some personalized attention. Okay, one by one student can ask and I can tell the names also. They are not much students. You are Arjuna batch. Anyways. Okay, yes. So the offer is still on. I don't know what will be the deadline. Again, I don't know when it will be getting ended. So just take the benefit. Let us take a break, all of you. Okay, break till. After break, we'll be talking about everything. Calorimetry. Should I take calorimetry? Hey, should I take calorimetry and then we will take a break? Or should I take a break, then we'll take calorimetry? I'm confused. Let's take a break. Okay, right. Hi, everybody. Hi. I'm sorry. I'm really sorry. Do not have time, bro. Okay, I'm really sorry. Sorry. Hey, I do have to, go. So we will quickly cover everything, okay? We will quickly cover everything. Student. So, the next immediate topic that we will be interested is your thermal expansion completed, Kadara. So let us talk something about calorimetry, okay? Let us talk something about calorimetry. Calorimetry, అందరికి చూడండి calorimetry ఇదే కదా? Yes. So in calorimetry we will be studying about how much heat is given to the object, how much the temperature increases. చూసుకోండి అంటే basically we will be applying some link to your heat and your temperature. ఇదిగో you are understanding? Yes, we will be applying a link between your heat and your temperature. Okay, right. Now what we will be doing is try to understand. Okay, now when you are applying the link to your heat and temperature, there are some terminologies. The first one is the specific heat. Okay, right. The first one is your specific heat. ఇదే కదా? Yes. Okay, specific heat అంటే ఏంటిరా? What do you mean by specific heat, sir? Specific heat is the, let me define the definition first of all. Okay? Let me just define the definition. The amount of heat required to raise, okay? The amount of heat required to raise 1 gram of substance. Ide kada? Yes. By 1 degree Celsius is known as your specific heat. Okay? Sir, so your specific heat is nothing but the amount of heat required to raise the temperature of 1 gram of that object by 1 degree Celsius. Andari, jagattaga chudandi. So let us go towards the any corner of the world, okay? Let us take 1 gram of any substance, let it be a metal, leda, it is the ice, leda, whatever it is, okay? Whatever it is, andariki chudandi. If you have 1 gram of the substance, and 1 gram kada? Yes. Usually it is represented by the letter C, okay? Try to understand. The usual representation stands for C. C and specific heat. Specific heat is nothing but the amount of heat required to raise the temperature of 1 gram of object by 1 degree Celsius. ఇప్పుడు చూడండి, if your 1 gram object needs C joule of heat లేదా we usually discuss it in calories, okay? Heat అంటే we usually discuss it in calories. అందరికి చూడండి. So C is the amount of heat that is required to raise the temperature of 1 gram of object. ఏదైనా object తీసుకోవచ్చు, okay? Whatever object it is, I don't care. 1 gram ఉంటే C. What about 2 grams? Can you tell me if 1 gram of substance requires C heat, 2 grams require 2C. ఇదే కదా? 3 grams చెప్పండి, 3 grams require 3C. 4 grams, hey, m grams చెప్పండి సార్. MC. For your m gram, MC, okay? MC is the heat required. For your m gram, MC is the heat required. ఇప్పుడు చూడండి, hey, all of you try to understand. ఇప్పుడు let us say this cube has the mass equals to m grams. All of you జాగ్రత్తగా వినండి, okay? Mass of the cube is m. M gram of mass is there. Correct. Very good. So for this m gram of mass, the heat required is MC. Heat required to what? Heat required to increase the temperature by 1 degree Celsius. ఇదే కదా? heat required to increase the temperature by 1 degree Celsius. Right? I'm not changing the masses. Let us keep the masses fixed. Choose 1 degree Celsius kosam MC heat required. 2 degrees Celsius kosam cheppandi ra 2 MC. Ide kada 3 degrees Celsius kosam cheppandi. Can I say 3 MC, sir? And similarly, T degrees Celsius లేదా delta T degrees Celsius గురించి చెప్పండి రా. Can I simply say, sir, MC into delta T? ఇదిగో. If you are understanding, well and good. If you are not understanding, formula గుర్తుపెట్టుకోండి. This is more than sufficient. Okay? Right. MC delta T అంటే if at all you have mg of object రా అందరికి చూడండి. Okay? You have mg of object. It must be in gram, okay? All of you. జాగ్రత్తగా వినండి. The mass must be in gram. If your specific heat is given as in gram, okay? Specific heat is given in gram, your mass must also be in gram only. If your specific heat is given in kg, then your mass should also be in kg. Okay? Sorry. Now, what I'm going to do is, let us try to take a PYQ. Leda. You try to understand, okay? When you are heating the object, let us take the best example of ice itself. So, if this is your ice, if this is your ice, what you're doing is you're heating this ice, kada? You will heat this ice. Ra. If this is your ice, what you're going to do is you're heating it. Ide kada? Yes. You are heating it. Now, there are 2-3 miracles, లేదా wonders that are going to happen. Okay? Now, there are 2-3 miracles that are going to happen. What is this, sir? First, చూసుకోండి. I want to observe the two parameters. Two parameters. The first parameter is the temperature. And the second parameter is the state. ఇదే కదా? First parameter అంటే మీ temperature and the second parameter is your state. Just a minute. Sir, as you are heating it, try to understand, all of you. As you are heating it, the temperature is definitely going to increase. Ide kada? Temperature, for sure it increases ra. Andarki chudandi. As you are heating it, the temperature increases. Okay, sir. Let us say the initial temperature, ante modatiga the temperature of this ice was somewhere around -5 degrees Celsius. Ippudu nenu heat chesina tarvata the temperature of this cube is increasing. Ide kada? Yes. So -5 degrees Celsius nunchi the temperature is jumping somewhere around 0 degrees Celsius. Chuskondi. What is happening ra? Your temperature change is happening. Ide kada? Yes. -5 degrees Celsius nunchi 0 degrees Celsius varaku your temperature is increasing. Point number 1 చూసుకోండి. Phenomena number 1. First, what's happening is change in the temperature. ఇదే కదా? Yes. దాని తర్వాత once the temperature has been achieved to 0 degrees Celsius, now try to visualize. Okay, try to visualize. It's the best thing that I'm going to tell you. Andariki. At 0 degrees Celsius, you keep on heating it, ra. You keep on heating it. What should happen, ra? Expectation at enti? What should happen, sir? What should happen? When you are heating it, temperature should increase. But it will not increase, ra. Andariki. ఈ స్టేట్ లో your temperature remains the same అంటే 0 degrees Celsius. కానీ the state changes. State changes అంటే solid to liquid. ఇదే కదా? Yes. So your ice was at solid. It got converted into liquid. ఇదే కదా? First your temperature increases. కానీ చూడండి -5 కదా? -4, -3, -2, -1 and 0 degrees Celsius. ఈ మొత్తం టెంపరేచర్ రేంజెస్ కోసం the state is same. Can I say that? అంటే ఒక స్టేట్మెంట్ గుర్తుపెట్టుకోండి రా. When your temperature changes, your state remains same. And when your state changes, your temperature remains same. ఇదే కదా? Yes. చూడండి. Your state is changing రా. స్టేట్ మార్చేస్తున్నావు కదా? ఈ కేసులో your temperature must be same. And what about the second case, sir? when your temperature is changing, your state must be same. And it should be solid only. Yes, correct. And this is the statement. Try to visualize all of it. Okay? If temperature is changing, state should remain the same. Yes, if the temperature is changing, state should remain the same. And vice versa cheppandi. If state is changing, cheppandi, temperature remains the same. Yes. Two factors. First is your state, second is your temperature. If you are increasing the temperature, phase should remain the same. If you are changing the phase, temperature should remain the same. Yes. So these are the most important boundary conditions that everybody has to understand. Choose one. And you have two different factors. Number one is your state change. Chudandi. Okay. Whenever your state is changing, you will analyze it in a different way. And whenever your temperature is changing, andariki chudandi. Ippudu temperature marchestundi andariki. There are two different terminologies. Okay. Ippudu terminology gurinchi chudandi. When your state is changing, we call it something known as latent heat. Okay. Concepts chudandi andariki. And when your temperature is changing, we call it as specific heat. Okay, right. Latent heat and specific heat. What do you mean by latent heat and what do you mean by specific heat? Okay, chudandi. Your latent heat, లేదా your specific heat అంటే it is the amount of heat required to change the temperature of 1 gram of substance. Hey, this is the biggest understanding, okay? By 1 degree Celsius. Let us take the example also. Okay? Try to visualize. Sir, mass is m gram kada? Your mass equals to m gram. And you are increasing and you are heating it. Hey, try to visualize. You are heating it. Okay? Sorry. You are heating it and you are increasing the temperature of m gram. Yes. So that means koncham samayam tarvata it will get heated up. Okay, temperature rises. Yes. So this is the heated object. Chudandi. Okay, temperature is 3 degrees Celsius. Chuskoni andariki. What you can say? Your total heat is equals to msc delta t. This is a comparison. But when your temperature is increasing, your state should remain the same. When your temperature increases, your state remains the same. Tell me here, e case lo cheppandi. You have state change kada? State change ante rendu changes unnayira. The first change is your state turns from solid to liquid. Yes, correct. And the second change is that your state of the object changes from liquid to vapors. This is your liquid. This is your vapor. This is your solid. This is your liquid. Yes. So when you are changing the state, only latent heat is required. Mass m unde idigora. To change the state, extra energy is required. Okay. To increase the temperature, energy is required. Kani, to change the state, some extra energy is required. Extra energy ante m into L. Chuskondi. Your heat required is equals to m into L. What is this L, sir? L ante latent heat. Finished. Depending upon the condition. So if it's melting unte you can simply say the latent heat of fusion. Ide kada? Yes, fusion ante melting ra. And if it is vaporizing, you can simply say sir heat is equals to m into LV. LV ante enti ra? Latent heat of vaporization. Finished. Ide kada? Yes. So this is latent heat of fusion. This is latent heat of vaporization, right? Depending upon the conditions, you have to take the situations. Choose. So that means if we do combination and entira, try to understand, okay? If you have a ice cube, me daggara ice cube unte, let us say the initial temperature of the ice cube is somewhere around minus 10 degrees Celsius, okay? You are heating it continuously. In minus 10 degrees Celsius nunchi, the temperature shifted to 0 degrees Celsius. State number 1, okay? 0 degrees Celsius. Idi kuda ice ra. State did not change. Chuskondi. Ice only. Kani, the temperature has changes. And when the temperature is changing, the state remains the same. Ide kada? Yes. State matrame same undali. Try to understand, okay? Try to understand. When you are changing the temperature, state must be same. ఒక్కసారి 0 degree Celsius అచీవ్ అయిందంటే మళ్ళీ హీట్ చేసుకోండిరా. ఏమైతుంది? వాట్ విల్ హ్యాపన్ సార్? ఇఫ్ యు ఆర్ స్టిల్ హీటింగ్ ఇట్, ఈ కేసులో చూసుకోండి ఫర్ అ వెరీ షార్ట్ ఇంటర్వల్ ఆఫ్ టైం ఇప్పుడు టెంపరేచర్ రిమైన్స్ ద సేమ్ 0 degree Celsius, కానీ స్టేట్ చేంజెస్ రా. ఓకే, స్టేట్ చేంజెస్ అంటే దిస్ ఫ్రమ్ సాలిడ్ రా. ఇదిగో ఇట్ ఈస్ సాలిడ్ కదా. ఎస్, from solid it is turning into liquid. And what is the temperature now? Temperature is still 0 degrees Celsius kada. Yes. So from 0 degrees Celsius ice to it is converting into 0 degrees Celsius liquid. Chuskondi. Again if you are heating it ra, malli heat cheste ఏమైతుంది సార్? ఇప్పుడు slowly the temperature increases. State change అయింది కదా. ఈ స్టేట్ చేంజ్ తర్వాత మీరు హీట్ చేస్తే the temperature simply increases అంటే 0 degree, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 వరకు స్టేట్ డస్ నాట్ చేంజ్ రా. ఒక్కసారి 100 degree Celsius అచీవ్ అయిందంటే యు అండర్స్టాండ్. ఓకే, ఒక్కసారి యువర్ 100 degree Celsius is achieved, that means you have reached the maximum limit for the liquid state. ఇప్పుడు మళ్ళీ హీట్ చేస్తే ఇట్ విల్ సింప్లీ ఇవాపరేట్, కానీ టెంపరేచర్ రిమైన్స్ ద సేమ్. వెన్ ద స్టేట్ ఈస్ చేంజింగ్, టెంపరేచర్ రిమైన్స్ ద సేమ్. వెన్ టెంపరేచర్ ఈస్ చేంజింగ్, స్టేట్ రిమైన్స్ ద సేమ్. ఇదే కదా. ఎస్. సో 100 degree Celsius లో మళ్ళీ హీట్ చేస్తే దిస్ కంప్లీట్లీ గెట్స్ కన్వర్టెడ్ ఇంటూ వేపర్స్ రా. 100 degree Celsius చూసుకోండి, ఇదే వేపర్స్ కదా. ఎస్, ట్రై టు అండర్స్టాండ్ ఆల్ ఆఫ్ యూ. లెట్ మీ జస్ట్ షిఫ్ట్ ఇట్ లిటిల్. ఇదిగో, ఓకే, రైట్. 100 degree Celsius లో వేపర్. దాని తర్వాత if I'm again heating this vapor, all of you try to visualize, okay? If I'm again trying to heat this vapor, చూసుకోండి ఏమైతుంది రా. 100 degree Celsius నుంచి it can increase now. Let us say 120 degree Celsius, లేదా 150 degree Celsius, లేదా 200 degree Celsius. Whatever temperature you want to give, you can give it. Okay? Right. కానీ ఒకసారి your vapor has been achieved అంటే you can increase the temperature to whatever you want. Try to understand. ఇప్పుడు let us see the application. అందరికి అప్లికేషన్ అంటే ఏంటిరా? టెంపరేచర్ మార్చేస్తున్నావు కదా. సో ఈ కేసులో your specific heat will be used. ఇదే కదా హీట్ ఫార్ములా చెప్పండి సార్. H is equals to m into C into delta T. ఇదిగో ఈ కేసులో యువర్ స్టేట్ ఈస్ చేంజింగ్, కానీ టెంపరేచర్ సేమ్ ఉంటే యూ విల్ యూజ్ అనదర్ ఫార్ములా. వాట్ ఈస్ అనదర్ ఫార్ములా సార్? యువర్ హీట్ ఈస్ ఈక్వల్స్ టు m into L. మళ్ళీ ఒకసారి యువర్ టెంపరేచర్ ఈస్ చేంజింగ్ అంటే యూ విల్ యూజ్ ద సేమ్ ఫార్ములా అగైన్. వాట్ ఫార్ములా సార్? H is equals to mc delta T. ఇదిగో యువర్ L అంటే latent heat of fusion, ఇదే కదా LF. Once you are 100 degree achieved, that means once again you will use the same formula. H is equals to m into latent heat of vaporization. And once your entire state has been changed to your gaseous state ante ee case lo you will simply say sir H is equals to mc delta T. Idigo. Now there should not be any confusion. All of you, you are understanding? Yes, you are understanding. It is not limited to your water, ice, solid systems. You can take metals also, increase the temperature of the metal ante heat cheskondi. Okasari you are heating the metal ante temperature increases and you will use the same formula H is equals to mc delta T for that. Ardhamaindi andariki? Right. Perfect. Now you want, let us take a PYQ also ra andariki. But is there any PYQ? Is there any PYQ? Oh. This all comes under calorimetry, okay? Just good. The quantities of heat required. To raise the temperature of it's a very easy question. Can anyone of you tell me the answer andariki? Sare, చూద్దాం. చూసుకోండి all of you. You can simply say, sir, R1 is 1.5 R2 కదా అంటే R1 upon R2 is equals to 1.5 రా. 1.5 ని 3/2 కూడా రాయొచ్చు కదా. ఎస్. సో ఇక్కడ నుంచి మీకు రిలేషన్ వచ్చింది రా. ఒకసారి R1 R2 గురించి రిలేషన్ వచ్చిందంటే మీరు సబ్స్టిట్యూట్ చేసుకోండి. సార్ ఆ ఫామ్ లో సబ్స్టిట్యూట్ చేయాలంటే see the formula, see the question ra. The quantities of heat required కదా అంటే H1 is to H2, heat 1 is to heat 2, H1 is to H2 కావాలి కదా. చూసుకోండి. The temperature is increasing ra. The temperature increasing అంటే చెప్పండి ఫార్ములా ఏంటిరా? mc delta T కదా. ఎస్, డివైడెడ్ బై mc delta T. C అంటే ఏంటి సార్? స్పెసిఫిక్ హీట్. డిపెండ్స్ ఆన్ మటీరియల్. రెడ్యూస్ ఫేస్ కాపర్ ఉంటే యువర్ సిసి గాన్. చూసుకోండి. డెల్టా టీ అంటే చేంజ్ ఇన్ టెంపరేచర్. 1 కెల్విన్ అంటే ఇది కూడా 1, ఇది కూడా 1. దిస్ ఇస్ ఆల్సో గాన్. ఇప్పుడు m1 అంటే మాస్ ఆఫ్ ఫస్ట్ స్ఫియర్, m2 అంటే మాస్ ఆఫ్ సెకండ్ స్ఫియర్. ఇదే కదా. మాస్ ఆఫ్ ఫస్ట్ స్ఫియర్, మాస్ ఇస్ డెన్సిటీ ఇంటూ వాల్యూమ్ కదా, డివైడెడ్ బై డెన్సిటీ ఇంటూ వాల్యూమ్ 2 రా. డెన్సిటీ కూడా గాన్. సో H1 upon H2 equals to V1 upon V2. Volume of first sphere upon volume of second sphere. Volume formula ఏంటి రా? 4/3 pi r cube కదా. Yes. So your V1 is nothing but 4/3 pi r1 cube divided by 4/3 pi r2 cube. 4/3 pi 4/3 upon కూడా gone. So you are left with r1 cube upon r2 cube అంటే r1 upon r2 whole cube రా. ఇప్పుడు చూడండి, R1/R2 వాల్యూ మీ దగ్గర ఉంటుంది కదా, సబ్స్టిట్యూట్ చేసుకోండి. ఒకసారి సబ్స్టిట్యూట్ చేస్తుంటే You are done with your answer. H1 upon H2 is equals to R1 upon R2 whole cube. And 3 upon 2 whole cube. 3 cube is 27. 2 cube is 8. Final answer is 27 upon 8. Ide kada? Simple questions. Correct. Okay? These are the simple elementary questions based on your specific heats and latent heats. Kavalante malli oka teesu. 1 gram of water, volume 1 centimeter cube, 100 degrees Celsius, converted into stream pressure under all these things. I don't think it's required. If you say to take, I will take it. Kani, I don't think there are much questions from this. Calorimetry completed. Andariki. Okay? Calorimetry completed. Cheppandi, edina doubts unte cheppandi. Ippudu, the only thing that I have to discuss is your conduction, convection and radiation. Ide kada? Yes. Conduction, convection and radiation. Because we are done with the calorimetry. Sorry. So let us talk about your conduction. There are no more PVQs. There are, but not useful. Once we are done with it, we will directly jump forward. Just go. So let us talk about the heat conduction. Andariki చూసుకోండి. Conduction kada? Yes. So now we are talking about your conduction. చూసుకోండి అందరికి. You must have the clarity for all three forms of heat transfer. అంటే మీ conduction, convection and radiation. You must be very good at understanding and explaining all these things. Okay? చూసుకోండి. Let us take one by one. So మొదటిగా conduction గురించి మాట్లాడతాం. అందరికి జాగ్రత్తగా వినండి రా. Okay? Conduction and ఏంటిరా? In conduction, you have a metallic object. Okay, try to understand. Conduction only works in conductors. Okay, conductor unte we talk about conduction. Ledante for insulators we don't talk about conduction of heat. Okay, they get burnt. Okay, they get burnt. We don't talk about conduction in case of insulators. Leda bad conductors of heat. Ardhamaindi kada? Yes. So we don't talk about calorimetry. ఇప్పుడే అయిపోయింది కదా. వాట్ ఆర్ టెలింగ్. ఓకే సరే. కండక్షన్ అంటే యువర్ మటీరియల్ మస్ట్ బి అ కండక్టర్. చూసుకోండి, ఏదైనా మటీరియల్ ఒకటే కండిషన్ అంటే కండక్టర్ ఉండాలి. ఫినిష్డ్. Step number 1, what you do is you connect the conductor across two different temperatures. Ide kada? Across two different temperatures. Step number 1, try to visualize. Okay, I am going in a very depth, but all of you must understand it. Choose. Okay, when you are maintaining a temperature difference between the two ends of a conductor. Okay, what I am telling, when you are maintaining a temperature difference between two ends of your conductor, on case low, what happens is the heat flows from higher temperature to lower temperature. Idigo, you are understanding? You try to visualize. This is higher temperature, hot, red hot. Kada? Yes. 100 degrees Celsius is the temperature surging. What about this? It's cold. Ice cold until 0 degrees Celsius. Idigo, you are maintaining a temperature difference now. Okkasari me temperature difference vaste, right? What will happen is slowly you will see that heat. Okay, heat. The heat will start flowing from higher temperature to lower temperature. This is the direction of flow of heat. Yes. Okay, let us do it. Don't worry. Okay, we'll do more questions also. Now, you don't worry, ఒక్కసారి యువర్ సిలబస్ కంప్లీట్ అయిందంటే ఐఎమ్ ప్లానింగ్ డీటెయిల్డ్ PYQ సెషన్స్ డీటెయిల్డ్ PYQ సెషన్స్. ఆ సెషన్స్ లో విల్ టేక్ లాంగ్ మ్యారథాన్స్ అంటే 12 hours of class only solving PYQs. Okay? Don't worry. So now when you are attaching this across two different ends of a temperature, అంటే 100 degrees Celsius and 0 degrees Celsius, your heat is fluid. ఇదే కదా, there is a lot of complicated scenarios. చూసుకోండి. Actually, the situation is much complicated. Because I want to explain in a simple way. Kada. There are a lot of heavy derivations. Right? If you are a JEE aspirant, you would come to know it. Can you try to understand? You have two states. Right? The first state is your steady state. Okay, steady state. And the second state is your, you can simply say pre-steady state. Right? Okay? Before steady state and your steady state. చూసుకోండి, all of you. When I have this conductor, okay, జాగ్రత్తగా వినండి రా, okay, జాగ్రత్తగా వినండి. When I have a conductor, let us say this is my conductor, okay, ఇదే నా రాడ్ రా. If this is my rod and I'm maintaining two different temperatures, చూసుకోండి, each and every point on this rod, అందరికి, okay, each and every point on this rod, I hope it is visible now. Try to visualize, okay? It's a rod now. If this is a rod, each and every point on this rod has same temperature. Chuskondi. Because it's a normal condition, kada. It's in the normal condition, ra. Ante same temperature. T. Try to visualize. I'm just talking about the temperature variations, okay? Temperature variations. Chuskondi. Each and every point on this rod, they are at the same temperature T. What you will do, you start connecting this rod across two different temperatures. And it is the, I will attach this rod to the two different ends. And let us say one end is a hot end, hot. And this, visualize it, okay, 100 degrees Celsius. And the second end is a cool end, ante ice, 0 degrees Celsius. What do you think will be the distribution on the points? Points ante telusa? Do you think the temperature will be same at each and every point on this rod? Here now also, do you think that the temperature at each and every point on the rod is same? Do you think the temperature is same? No, simply no. Try to visualize. What will happen is, try to visualize, hey, this is Kaligeya, okay? Hey, temperature ante Kaligeya, heat, okay? Kaligeya ra, hey, Kaligeya. They are entering now. Okay? Kaligeya army entering. Eppudu they are entering into this valley, kada? Yes. Kaligeya is entering into the valley. Where is it? I don't know what's happening, but today is very irritating day for me, Anyways, choose good. So as they are entering, right, try to visualize, okay? They are entering now. So they will do all these disruptions, okay? All these disruptions. And they will increase the temperature. You are understanding? As they are entering, the temperature is increased. And chudandi, E point low 100 degree unte, here will be 80 degrees Celsius. For example, okay, I am giving you an example, 60, 40, 20, 10, 0. You are understanding? The temperature is arranged. Ide kada? Try to visualize. Once this temperature has been set, you are understanding? Ante your mottam Kaligeya army, it has crossed this entire road. The effect is seen kada? Chuskondi. Temperature has been changed. Temperature changed ante your heat has been traveled. And of course, your heat has traveled into the rod. That means the temperatures now will not change. Ante enti sir? Ante once this is 80 degrees Celsius, it will remain 80 only. It will remain 60 only. It will not change, right? It will not change. At the same time, ee point ki temperature 40 unte, it will remain 40 only. 20, 10, 0. Ardhamindi? Yes. Now the temperature change ante you have made the favorable condition for the heat to flow. ఇప్పుడు the temperature changes, చూసుకోండి ఇదే కదా, they are the temperature changes రా. Due to these temperature changes, a constant amount of heat, what I'm telling అందరికి చెప్పండి, a constant amount of heat flows through this rod. అర్థమైంది? Now once a constant amount of heat is flowing, ante the state is called as your steady state. చూసుకోండి. What about pre-steady state, sir? This is the most complicated state. చూసుకోండి. Pre-steady state ante what ra? I'll just give you the introduction. Okay, I'm not going to express much about it. చూసుకోండి. If this is your container andariki, if this is your rod ra, try to visualize. Okay, let us say you have attached one end at the hot surface ante ide 100 degrees Celsius ide kada, and the other end to cold surface ante let us say ice ra, ice unte 0 degrees Celsius. What about the temperature, sir? Let us say each and every point on the rod is at the same temperature. Same temperature and enti, sir? 20 degrees, 27 degrees Celsius. Ardhamaindi? Each and every point on the rod before attaching is 27 degrees Celsius. Okasari meeru attach cheste this temperature will change ra, kani it will change differently for different positions of this rod. అర్థమైంది? అంటే ఈ రాడ్ పై ఉంటే వేరే పాయింట్స్ కోసం the temperature behaves in a different way. ఇదిగో 27 కదా, it will increase from 27 to 100 రా, and last point it will decrease from 27 to 0 degrees Celsius. Understanding? And the remaining temperature, mighty temperature, they will arrange in themselves in such a way. This process of setting the temperature differences, you are understanding? This process of setting the temperature differences is known as pre-steady state. Once your temperatures have been fixed, until you can say it is a steady state. And me steady state lo gurtupettukondi, always the heat current is constant. Until the constant amount of heat is flowing in every second through your rods. Ardhamaindi andariki? Right. So me steady state lo you can simply say that your heat current is same, constant, uniform. Ardhamaindi andariki? Right. So let us take one more case ra. Okay? Let us take one more case andariki. Let us say this is my rod. Okay? This is my rod. This is my rod. All of you try to visualize. Now let us say I am attaching this rod to two different ends. Andariki. So ide na first end at 100 degrees Celsius, and this is my second end at 0 degree Celsius. So two different temperatures kada. What will happen, sir? Now the heat will flow. Heat will flow ante, can I simply say the heat flows from higher region to lower region? Very good. Ide kada? Yes. The heat will flow. How much heat, sir? Let us say Q amount of heat is flowing in 1 second. You are understanding? Q. Heat is Q. Andariki chudandi. Heat is the energy ra. There is a difference between your heat and temperature. Temperature is the measure of hotness or coldness. Kani heat is the actual form of energy that is flowing. Ante kada? Yes. Chudandi. So when you say that you have a heat flowing, we defined a terminology, heat current, IH. Hey, current electricity lo we used to define current kada. Current is equals to I is equals to V upon R, leda V equals to IR. Ekkada kuda we will be defining the same terminology, heat current IH. Heat current IH, cheppandi, what is it, sir? Sir, that is simply equals to dq upon dt. Idigo. This is your heat current ra. Notations, terminologies, gurtupettukondi. Okay, these are the understanding. These are the understandings ra. So from here you can simply say sir, yes, so I was telling you that if at all you have two different temperature, your heat will be flowing and the rate of heat flow is known as heat current I. Andariki chudandi. Formula, I'm not going into the proof and all these things. We don't have much time, okay? Directly formula రాస్తున్నారు చూసుకోండి అందరికి. ఓకే అందరికి. Your heat current IH equals to dq divided by dt. Formula గుర్తుపెట్టుకోండిరా. K A delta T divided by L. K A delta T by L. Yes. What is K, sir? What is K, sir? What is K, sir? What is K, ra? What is K? What is A? What is delta T and what is L, ra? ఇప్పుడు మీకు క్లారిటీ ఉండాలి. Okay, what is K? What is A? What is delta T? What is L? So let us explain it using one more diagram. So if this is your cylinder, okay, I would say if this is your cylinder, okay, let us say the radius of this cylinder is A R. I'm just directly giving you the area, okay? Area తీసుకోండిరా. Radius R ఉంటే you can simply say that area of phase is equals to pi r square. ఇదే కదా చూసుకో. Area is A అంటే pi r square. What is L, sir? L అంటే the length across which the current is flowing. ఇదిగో. The biggest good news is that you don't have much complicated questions. ఈ cases లో మీరు JEE question చూసి you will be gone. Okay? They ask something like this, ra. You have a cylinder, something like this. Try to visualize. Okay? This is the first cylinder, and this is the second cylinder. ఇదే కదా? Yes. The internal part is connected at temperature T1. External temperature is T2. Heat is flowing radially outwards. ఇదిగో. ఈ case లో you should be understanding what is the value of L, what is A, and all these things. Integration and all these things are there. చాలా కష్టం. We don't have all these things, right? We'll simply go and we'll simply say that L is the length across the conductor. A is the area of the phase. Delta T and TNT change in the temperature. Temperature change across any 2 points. Not at the ends, not at the ends. గుర్తుపెట్టుకోండి. Delta T అంటే change in the temperature across any 2 points on the conductor, not at the end points. ఇది చాలా పెద్ద మిస్అండర్స్టాండింగ్స్. ఓకే, ఎస్. సో యువర్ లెట్ మీ జస్ట్ రైట్ ద ఫార్ములాస్. ఈ ఫార్ములాలో యువర్ K అంటే ఇట్స్ అ కోఎఫిషియంట్. వాట్ కోఎఫిషియంట్ సార్? కోఎఫిషియంట్ ఆఫ్ థర్మల్ కండక్షన్ అంటే కాన్స్టెంట్ నంబర్. ఇదిగో కాన్స్టెంట్ నంబర్. వాట్ అబౌట్ A, సార్? A అంటే ఇట్ ఈస్ ద ఏరియా perpendicular, okay, area perpendicular to the direction of heat flow. What about delta T, ra? Delta T idigo. Delta T ante temperature difference. Ide kada? Yes. Delta T ante it is the temperature difference across any 2 ends, ra. Cross any 2 points on conductor. Lastly, what is L, sir? L ante the length across which the heat is flowing. Ante kada? L ante length. Idigo. Finished. Okay, sir. Now let us try to understand. Andarki cheppandi. So let us say analogy of heat current with respect to Ohm's law. ఓమ్స్ లా అంటే ఏంటిరా? మీ ఓమ్స్ లాలో యూ హ్యావ్ అ రెసిస్టర్, అదే కదా? ఎస్, యూ హ్యావ్ టూ డిఫరెంట్ పాయింట్స్ సార్, విఏ లేదా V1, దిస్ ఈస్ ద సెకండ్ పాయింట్, విబి అంటే V2. రెసిస్టర్ ఇస్ ఆర్, కరెంట్ I. చెప్పండి, వాట్ కెన్ యూ సే సార్? యువర్ కరెంట్ ఇస్ నథింగ్ బట్ ద చేంజ్ ఇన్ పొటెన్షియల్ డిఫరెన్స్, ఇదే కదా? కరెంట్ ఎలక్ట్రిసిటీ ఐ హావ్ టోల్డ్ యూ ఇన్ డీటెయిల్ ఆల్ దిస్ థింగ్స్. డెల్టా V అపాన్ R, ఇదిగో అంటే V1 minus V2 upon R, ఇదే కదా? ఎస్. At the same time, if you have a rod, అందరికి చెప్పండి, మీ దగ్గర ఒక రాడ్ ఉంటే what will you write రా? Temperature చెప్పండి. Here potential is VA, let us say temperature is TA. Potential VB ఎక్కడ ఉంటే temperature is VB, TB, ఇదే కదా? Yes. What about the information sir? Length L తీసుకోండి, కాన్స్టెంట్ లేదా కోఎఫిషియంట్ ఆఫ్ థర్మల్ కండక్టెన్స్ K తీసుకోండి, యువర్ ఏరియా ఇస్ సింప్లీ ఈక్వల్స్ టు A. కెన్ యూ టెల్ మీ ద ఫార్ములా ఆఫ్ I రా? I అంటే dEq అపాన్ dt కదా? చెప్పండి, వాట్ ఇస్ ఇట్ రా? వాట్ ఇస్ ఇట్ సార్? KA డెల్టా T డివైడెడ్ బై L, ఇదే కదా? అంటే K ఇంటూ A ఇంటూ డెల్టా T అంటే ఏంటిరా? T1 మైనస్ T2 హోల్ డివైడెడ్ బై L, ఇదే కదా? ఎస్. లెట్ us rearrange the terms రా అందరికి. Send this downwards. Can I simply say, choose what if you are understanding it or not? T1 minus T2 divided by L upon K. అర్థమైంది? Yes, this is something. Okay, right. Now you compare the two equations అందరికి. So మీ current electricity లో your Ohm's law I is equals to V1 minus V2 upon R. And your heat current IH is equals to T1 minus T2 divided by L upon Ka. ఇదే కదా? Yes. So that means this R is equivalent to L upon Ka. Oh my God. అంటే ఈ మొత్తం terminology, what terminology sir? Your L divided by K into A, we will call it, చెప్పండి, thermal resistance. Yes, we call it thermal resistance రా. That means the same things అంటే ఏంటి సార్? Simply it's resistance sir, it's resistance. Resistor ఉంటే you can simply say you have a combination of resistors కదా, R1 R2 series లో ఉంటే you can simply say sir R net is equals to R1 plus R2. Same thing రా, same thing here also you say the same thing. అంటే మీ దగ్గర రెండు రాడ్స్ ఉంటే let us say first rod and let us say this is your second rod. అందరికి చూసుకోండి, ఇదే కదా? ఇదే మీ సెకండ్ రాడ్. లెంత్ అంటే L1, హియర్ ద లెంత్ ఇస్ L2, ఏరియా ఇస్ A1, ఏరియా ఇస్ A2, కండక్టివిటీ ఇస్ K, థర్మల్ కండక్టివిటీ, ఓకే, కాన్స్టెంట్ కోఎఫిషియంట్, హియర్ ఇట్ ఇస్ K2, ఇదే కదా? ఎస్. సరే what you can say ra? You can simply say sir your R net is equals to R1 plus R2. చెప్పండి, what is the value of R1 sir? R1 value is L1 upon K1 A1 plus L2 upon K2 A2. ఇప్పుడు there might be conditions in which R net kada, R net ante you can take something like this. What is net length of the conductor sir? L1 plus L2 divided by K net into A net. ఇదిగో, this is a formula. Okay, right, correct. L1 upon K1 A1 plus L2 upon K2. ఇప్పుడు there might be some special cases also. Special cases అంటే ఏంటి? Sometimes they will say area is same, sometimes they will say lengths are same. Okay, area same ఉంటే you don't have any problem. A1 equals to A2, you can simply take it out, you can do the work by yourself. ఇదే కదా? I'm not going into the questions part for now. We have no time left. చూసుకోండి. What about parallel రా? చెప్పండి, parallel కోసం what you can say is, చెప్పండి, for parallel resistance is parallel ఉంటే ఇదే మీ R1 resistor and this is your R2 resistor, ఇదే కదా? Yes. So when you replace ఈ entire system ని ఒక ఈక్వివాలెంట్ సిస్టమ్ తోనే మార్చేస్తుంది, what you will get రా? You will simply say sir R net is equals to R1 R2 divided by R1 plus R2 same similarities రా చూసుకోండి. You can simply say sir, if this is your first rod, okay, ఇదే మీ first rod ఉంటే, is it correct? Yes. So this is your first rod. And next చెప్పండి, this is your second rod. ఇదే కదా? Yes. So these are your two rods. Try to visualize. But all of you, but there must be potential difference kada. చూసుకోండి, V1 V2, then only then this assembly keeps significance ra. ఇక్కడ కూడా the same thing should be there ra. This should be connected to a common end. Common end అనేది తెలుసు అందరికి. That means these should be attached something like this. చూసుకోండి, this temperature is T1 and this temperature should be T2 ra. Then and only then your entire discussion is useful. లేదంటే this is completely useless. ఇదే కదా? Try to visualize. Length same ఉంటుంది రా. చూసుకోండి, if length is L, ఈ కేసులో the length is L, here also length is L కదా? Yes. Conductivity K1, conductivity K2. What about areas రా? Area is A1, area is A2. చెప్పండి, what you will say sir? 1 upon R net equals to 1 upon R1 plus 1 upon R2. ఇదే కదా? 1 upon R net అంటే ఏంటి రా? R formula is L upon KA కదా? You simply say sir, K net into A net divided by L net is equals to K1 A1 upon L1 plus K2 A2 upon L2. అందరికి చూసుకోండి, L1 is equals to L2 is equals to L. Denominator same ఉంటే directly add the numerators. ఇదిగో finished. అంటే you will simply say sir, divided by L, it is K1 A1 plus K2 A2. ఇది కూడా చూడండి, నెట్ రెసిస్టర్ కి కూడా the length is the same రా. అంటే K net A net is equals to K1 A1 plus K2 A2. అర్థమైంది? Yes. You can simply replace these two with another system. Very good. Okay, right. So this was all about your conduction. Am I forgetting something? Tell me. If I am forgetting something, tell me andariki. Now, what are the types of questions that are asked? చూసుకోండి, the major types of questions that are asked from this combination is something like this. Try to visualize, okay? It will tell you that you have two different rods, okay? This rod has length equals to L, and for example, చూసుకోండి, this rod has length equals to 2L. ఇదే కదా? Yes. Let us say thermal conductivity, the coefficient is K1, here it is K2. చూడండి, okay, it will give you the ends అంటే తెలుసా? temperature and the end points రా. ఇదిగో, this temperature at this end equals to 100 degrees Celsius and the temperature at the other end is equals to 0 degrees Celsius. Finished kada? When you have a temperature difference, it might ask you to find the temperature at the junction. This is a very classic problem and very standard, okay? Multiple times asked in multiple PYQs. Andariki, yes, area is the same. In case low, your area is the same. So how will you find it, sir? Modatiga, you write the net resistance. Ela ravali, sir. Your net resistance is equals to R1 plus R2. ఇదే కదా? R1 చెప్పండి, L1 divided by K1 into A plus R2 చెప్పండి సార్, L2 into K2 into A. ఇదే కదా? L2 divided by K2 into A. L1 వాల్యూ ఎంత ఇచ్చారు సార్? L divided by K1 into A plus L2 వాల్యూ ఎంత రా? 2L divided by K2 into A. ఇదిగో. What about R net రా? R net కోసం net length చెప్పండి, 3L divided by K net into A. ఇదే కదా? LA gone. అర్థమైంది? So you are left with 3 upon K net is equals to 1 upon K1 plus 2 upon K2. ఇదిగో, అర్థమైంది? You want to do the cross product and write the values by yourself. Directly రాసిన చూసుకోండి ఇద్దరికి. K net is equals to it correct? Yes, it's correct. It's correct only. Correct only. Yes, correct. Sir, now you simply write, sir, your I ante dq by dt kada k net a net into delta t upon L net. Idigo. Across the total lengths kada k net value anta sir 3 k1 k2 a net value ante a delta t value anta chopra 100 kada 100 minus 0 is 100 divided by your total length is 3L. ఇదే కదా? Yes, this is your current రా. ఒకసారి మీ స్టడీ స్టేట్ అచీవ్ అయిందంటే this current will remain the same రా. ఇదిగో this value will not change. అందరికి అర్థమైంది కదా? This value will not change. ఇప్పుడు when you have this value, you do the independent calculation for this rod రా. ఇదిగో you take independent calculation for this rod. చెప్పండి ఈ rod కోసం your I value is K1 A1 delta T1 divided by L1. ఇదే కదా K1 value ఎంత ఇచ్చారు సార్? K1 is K1 only. A1 value ఎంత? It is A only. Delta T గురించి చెప్పండి 100 and let us say the temperature is X. X delta T చెప్పండి సార్ 100 minus X divided by length చెప్పు ఒకసారి it is L. అంటే this much of the current is flowing through this rod. కానీ ఈ current and E current, they must be same రా. ఎందుకంటే steady state has been achieved. So equate చేసుకోండి ఈ రెండు ఈక్వేషన్స్ ని. What you get is, they should have write it రా. Let's shift it this side. I'm shifting it. చెప్పండి అందరికి. సో యూ విల్ సింప్లీ ఈక్వేట్ దీస్ టూ కదా? ఎస్. సార్ యువర్ కేనెట్ ఇంటూ కేనెట్ వాల్యూ వచ్చింది కదా, డైరెక్ట్లీ రైట్ ఇట్ రా. రైట్, ఐమ్ సారీ. ఓకే, యువర్ కేనెట్ ఇస్ సింప్లీ ఈక్వల్స్ టు 3k1 k2 divided by k2 plus 2k1 into a net is a only. Okay, delta t is 100 divided by 3L should be equals to this current రా. ఇదిగో this current అంటే K1 A 100 minus X divided by L. What is gone, sir? Your A, your L gone. అర్థమైంది? You are left with these two equations. చెప్పండి. So you can simply say ఇక్కడ నుంచి what you will say రా. So this is 100 into 300. So you can simply say, sir, 300 K1 K2 divided by 3 into K2 plus 2K1. 3 into K2 plus 2K1. ఇదిగో 3 1s are 3, 3 3s are 100. అంటే 100 K1 K2 only. ఇదే కదా? That must be equals to K1 into 100 minus X. What is cancelled, sir? K1 gone. 3 1s are 3, 300. So what you are left with is something like this. 100 K2 divided by K2 plus 2K1 is equals to 100 minus X. You send it that side, you send it this side. What you are left with, your X is equals to 100 into, చెప్పండి, 100 into 1 minus K2 divided by K2 plus 2K1. ఇదిగో. So you can simply say that is 100 into the subtraction 2K1 divided by 2K1 plus K2. This is your value at the junction. If I'm doing some mistakes, pardon, okay? Sorry. So this is how the questions are asked now. దాని తర్వాత we'll talk something about the next mode of heat transfer, అంటే మీ convection. ఇప్పుడు convection గురించి చూద్దాం అందరికి. What is convection రా? Your convection. Yeah, is known as convection. For example, let's discuss some more questions. Okay? heating it. Sorry. So what you have is a liquid. చూడండి అండి. You are having a liquid. Water తీసుకో. You have a water in a conductor. You are heating it రా. అందరికి చూసుకో. When you are heating the water, what is happening ante, you know this property kada, hot water is less dense than cold water. Because andariki ardhamayindi kada, it is class 8, 9, 10 concept ra. The hot water is less denser than the cold water. Your lecture will be completed by 6:15, at most 6:15, okay? Don't worry. Yes. So your hot water, idigo property gurupettukonira, your hot water is less denser than your cold water. Do you remember this property? Yes. Okay. You are telling her, I'm not understanding. I did not understand, okay? Sorry, pardon me, I did not understand your words. Anyways, చూసుకోండి. So what will happen is, try to understand. When you are heating it, the immediate water atoms, the water molecules that are close to the surface, these water molecules, they get heated, yes. Once they get hot, what they'll do is the density decreases, and దాని తర్వాత they'll go up. ఇదే కదా? Yes. No, 6:15, 15, 1:05. 1:05. So once your molecules have been heated, they will go up, ra. చూసుకోండి, they'll go up. ఇక్కడ కూడా your molecules are heated, they will go up. Okay, your molecules are heated, they'll go up. Okay, they'll go up, ra. కానీ in this process, when your molecules are going upwards kada, when your molecules are going upwards, ఈ ప్రాసెస్ లో whatever heat they were having, అందరికి చూడండి, whatever heat they were having, they are transferring it to the another particles. చూసుకోండి, whatever heat they are having, let us say here is a water molecule, అందరికి చూసుకోండి, this is a water molecule. So what happened, this water molecule over here, it went up and it gave its energy to this ra. And ఒకసారి as energy has been lost, it will return back. Why, sir? Because it became cold. చూసుకోండి రా, you keep your target only on this water molecule. అందరికి, this is a water molecule కదా? Yes. It will go up and give the energy to this water molecule. ఒకసారి the energy has been given, once it is giving the energy, అందరికి చూడండి, once the energy has been given అంటే this water molecule loses the energy అంటే loses heat అంటే becomes cold water is more denser. దాని తర్వాత it will return back to the original position, then go up, then return, then go up, then return, then go up, then return, something like this. Try to visualize each and every single water molecules. They'll go up, give energy, come back, go up, give energy, come back. Are you understanding? అంటే the actual flow of medium particles, these are your medium particles, they are flowing. అర్థమైంది? Yes, so this is the actual flow of medium particles, and this flow is conducting heat kada. So మీరు, if you are observing it from the beginning itself, surface ni observe చేసుకోండి. Initially when you started heating, surface temperature T is equal to 27 degrees Celsius. ఇదే కదా? కొంచెం సమయం తర్వాత the temperature has risen to 40 degrees Celsius. ఎలా వచ్చింది? Because the water molecules, they are actually coming up and giving the heat. అదే సరే, గుడ్. Okay, this is known as convection. You don't have much about it, you literally don't have much about it. Okay, you don't have formula also. Okay, you don't have formula also, but you must understand the concept. Okay, sorry, good. And lastly, the biggest or the most interesting topic is your radiation. Radiation అందరికి లాస్ట్ టాపిక్ ఆఫ్ ద డిస్కషన్ రేడియేషన్ గురించి చూద్దాం. Correct. Perfect. So, sir, try to visualize radiation and TNT. What all two types of heat transfer we have seen till now? Ante me conduction and convection. Both of them require medium ra. Yes. Ante me conduction kosam meeku medium kavali. Ade same story for your convection. Kani radiation lo you don't need medium at all. You don't need medium at all. Why is that? Because let us talk something about your Prevost theory. I'm doing some mistake in the spelling, tell me, okay? I'm not good at spelling, okay? Prevost theory, what does it say now? The theory simply states that, if you have a metal, if you have a metallic object, leda conductor, yedina object it is, not a metal, only yedina object, this one, any object. When you are talking about any object, we'll talk about two things. Two things on TNT, sir. We'll talk about absolute zero temperature. First condition is absolute zero temperature. And the second thing we will be talking about non-absolute zero temperature. Yes, I don't want to hear anything. I only want to talk about if it is absolute zero or it is not absolute zero. Choose. If the temperature is absolute zero, ante e point of time low, your electrons, your atoms, they will not vibrate at all. They have zero energy. Absolute zero temperature enta, sir? 0 Kelvin, minus 273 degrees Celsius. In temperature low, you can say that the vibrations of the atoms, they are gone. Ante became zero. Except this absolute temperature, meeku yedaina temperature kavale teeskondi. At each and every single temperature other than absolute temperature, the atoms are actually vibrating. Ide kada? Yes. Each and every atom is vibrating. Andariki cheppandi. At any non-absolute temperature, the atoms vibrate. Vibrate ante telusa andariki. The atoms vibrate. Ante the electrons and protons that are there, ante charged particles. Atoms vibrate ante the charged particles, the charges inside the atoms, they also vibrate. Ante if the charges are vibrating, andariki, jagrataga vinandi. Okay? When you are saying that the charges are vibrating, ante accelerating. Charge is accelerating. Maxwell's laws. What is it? An accelerated charged particle emits radiation. EM waves gurtunda. EM waves lo, if your charges are vibrating, ante they must emit radiation. Ide kada? They must emit radiation. Kabatti each and every single object, whatever it is, even it at 0 degrees Celsius, choose even at 0 degrees Celsius, your vibrations are not zero. There are some vibrations. And those vibrations are vibrations of charged particles. And those charged particle vibrations emit the radiation. Ippudu the radiation ante your EM waves. EM waves do not require any medium to travel. They are non-mechanical waves. We discussed in your EM waves. They are non-mechanical waves. And they do not require any medium to oscillate or travel. Each and every single object emits some radiation. This is Prevost theory. It says that every object at non-zero temperature. When I say non-zero temperature, it is 0 Kelvin. Okay, non-zero Kelvin emits radiation. Understanding? Finished. అంతే కదా. Yes. ఇప్పుడు let us talk something about your Kirchhoff's. Okay. Yes, let us talk something about your what does it say? Huh? What does your Kirchhoff's law state? Can anyone of you tell me the statement? Can anyone of you tell me the statement for your Kirchhoff's law? Hey, yes, I have seen it, but don't spam. Don't spam. Hey, don't spam. నాకు స్టేట్మెంట్ కావాలిరా. The statement for leave it. Leave the chat section. Leave the chat section. Sir, so your statement simply says that good absorbers finished. Yeah? Statement. Yes. That means, చూసుకోండి, your absorption is a different phenomena and your emission is a different phenomena. Okay, both are different. అందరికి జాగ్రత్తగా వినండి. When you talk about your absorption, all of you visualize, okay? If this is your object, let us say TO ante temperature of object, TS ante temperature of surrounding. Okay, TO ante temperature of object, TS ante temperature of surrounding. Very good. What will happen if the conditions, there are some conditions. What are the conditions? The conditions are like this. If the temperature of object is more than temperature of surrounding, what will happen, sir? What will happen? The heat లేదా the radiation will be emitted. ఇదే కదా? Am I correct? Next, చెప్పండి. If temperature of surrounding more than temperature of object, heat will be absorbed. Lastly, if temperature of object also temperature of surrounding, no heat exchange. No, not like that. Good absorbers are not bad reflectors. Yeah, you can say. Yes, you can say good absorption and bad reflection. Sorry. Understanding, not understanding. Just one. This statement is partially correct and partially incorrect. Enduku sir? Why sir? This is for sure correct, Ra. This is for sure correct. Whatever be the case, statement number 1 is 100% correct. And if your temperature of object is more than surrounding, energies will be emitted. Kani. At the same time, it does not matter. Radiation ante, it does not need a medium, Ra. If you need a medium, then the medium has some boundary conditions. Our boundary conditions ante temperature high undali, surrounding temperature low undali, all these things. Here there is no medium. If there is no medium, the absorption and the emission happens simultaneously. Ante enti ra? Let me break a misconception, all of you. If you are having a sphere at 100 degrees Celsius, your surrounding temperature is around 60 degrees Celsius. I am telling you an example, okay? Try to understand. It will for sure emit radiations. Yes, it is emitting, Ra. It is emitting. But at the same time, it is also receiving the radiations. You are understanding? Not only this case, mottam cases lo, even if your temperatures are same, not same, whatever it is, the temperature, the radiation or the heat, it is emitted also, absorbed also. It's not KCL, KVL, Ra. Okay? Now, let us go or let us see a flow diagram, Ra, modatiga, because you will not understand it till I explain it to you. If I say I have the object, choose code. I'm not considering the fact of emission, okay? You forget about emission, Ra. You only visualize that you are throwing some incident radiations on this object. Try to visualize, okay? Try to visualize. Okay? Yes. So you simply say, sir, this is the incident power. P incident kada. This is your incident power. Now, the biggest question is, what next? Next ante rendu cases unnai. First case lo, your object is a perfect black body. You are understanding? First case lo, your object is a perfect black body. And second case lo, your object is not a black body itself. Okay? Not black body. Idigo. Perfect black body ante enti ra? Whatever amount of radiations you throw into it, it will absorb each and everything. You are understanding? Yes. So perfect black body unte, you visualize, okay? If you have a perfect black body, if you have a perfect black body, why black, sir? Why black? Because black is the best absorber. Try to visualize. This board is black, kada? No, it is not black, Ra. There are some colors mixed into it. Absolute black until nobody knows. You visualize. YouTube lo, you go and search the perfect black room. Okay? If you want to understand YouTube lo, after this class, go and search perfect black room. You will come to know that even those black rooms that are specially designed, they are also not perfect black. They also reflect some light. You are understanding? Ante, me perfect black body kosam, there should be no reflection. Try to visualize. Okay? There is no reflection. Ante, whatever light you throw on it, absorbs. And perfect black body does not exist in real life. It is a complete theoretical topic, Ra. You are understanding? Right. Now, let us understand the absorption first. Okay, yes. So you are having a black body, you have thrown some light, it has absorbed all of it. Ardhamaindi? Yes. Once the absorption has been completed, try to visualize. once the absorption has been completed, ఇప్పుడు the black body got some energy, heat energy kada, electromagnetic radiation energy ra, it received the energy, but in the universe nothing is happy with energy. అంటే ఈ యూనివర్స్ లో ఎవ్రీథింగ్ ట్రైస్ టు బి అట్ అ మినిమమ్ ఎనర్జీ లెవెల్. యూ ట్రై టు అండర్స్టాండ్, యువర్ అండర్స్టాండింగ్? ఎస్. That means if it received 100 joule of energy, it is not happy. After some time, it will emit all of it. Hey, I don't want it, throw it. Understanding? So it emitted 100 joule of energy only. Try to understand. That is the difference. So if you have a black body, okay, perfectly black body, you are throwing 100 joules, it will absorb. For sure, it will absorb all of them, but not happy. So what it will do is, after the absorption has been completed, ఇప్పుడు it will throw out completely రా. సో ఎమిషన్ ఎంత సార్? 100 joule is the emission. ఇదిగో. What about a non-black body రా? Non-black body చెప్పండి. Non-black body. What do you do, sir? For non-black body, we gave 100 joule. చూసుకోండి అందరికి. You gave how much రా? 100 joule. It absorbed only 20. ఎంత? Only 20. How much it will emit రా? Whatever it has, it will emit. It has 20. So 20 will be gone. ఇదే కదా? Yes. So it will emit 20 joules. ఇదిగో. So here the total incident radiation was 100. ఎక్కడ కూడా total incident radiation అంటే 100. Absorption complete 100. Absorption 20. Emission 20. Emission 100. You are understanding these relationships, ra? Sir. Now, let us discuss some terminologies. First terminology is your absorptivity. Absorptivity ante idigo. This is nothing but the radiation incident divided by the radiation absorbed. Ide kada? No. Radiation absorbed divided by radiation incident. Leda, you simply say, sir, it is simply equals to the absorbed radiation divided by the total incident radiation. Ide kada? Yes. Divided by incident radiation. Idigo. You are understanding? In case lo, how much was absorbed ra? 20. How much was incident ra? 100. What is absorptivity, sir? 0.2. General, sadhananga, your absorptivity is less than 1. Arthamayindariki? Yes. What about the emissivity ra? There is one more terminology. I'll write it here. Okay, choose one. We will discuss something about your emissivity. Andariki. Ante era. What is emissivity, sir? Sir, it is nothing but the emissivity, లేదా the emission of a general object. Divided by emission of black body. ఇదే కదా? Yes. Emission of black body. చెప్పండి రా. What is the emission of general object? 20 received, 20 emitted రా. అదే. What do you mean by emission of black body రా? 100 received, 100 emitted అంటే 100. ఇది కూడా 0.2. And generally, your E also less than 1. Understanding? Alright. I'm just telling you so that you get a feel of it. Okay? Now, for a perfect black body, your absorptivity is 1 and your emittivity is also equals to 1. Understanding? Yes. Correct. Once this has been completed, let us go towards your Stephen's law. So, let us talk something about your Stephen's law. Spelling చూసుకోండి ఒకసారి. Stephen's law కదా? Your Stephen's law talks simply about the heat energy radiated లేదా radiation power emitted. Okay? Your Stephen's law talks about the power లేదా radiation power emitted. Okay? Let us say you have the object andariki and the area is A temperature of this object is T. ఇదిగో area A, temperature is T. చూసుకోండి. This Stephen's law is only designed for your black body. Okay, yes, this Stephen's law is only defined for a black body. Digo, you are understanding? Yes, this is only defined for a black body. Jagrataga vinandi andariki. Understanding? When he was defining his law, he only defined it for black bodies. There was a scientist, Boltzmann. He extended the discussion for entire objects. We'll see that also, don't worry, okay? He said that whatever heat that is flowing per unit time, dq upon dt, heat current, current, radiation current, leda radiation energy per unit time. It is directly proportional to the area, the surface area, and at the same time, the current, it is directly proportional to the temperature of object to the power 4. Understanding? You combine both of them, you will say, sir, dq divided by dt is equals to, leda, it is directly proportional to a into t to the power 4. Directly proportional kada, replace it with a symbol, constant and equal and constant sign kada, yes. So simply says that here dq upon dt is equals to some constant, ee constant ante sigma ante Stephen's constant. Andariki chusko, it is sigma into a into t to the power 4. This is your energy. dq upon dt is equals to sigma a t to the power 4. అర్థమైంది? Yes. What is it? Heat emitted అంటే heat that is flowing out of the object. ఇదిగో heat that is flowing out of the object per unit time is given as sigma a t to the power 4. ఇదే కదా? Yes. కానీ this was for only black bodies రా. So Boltzmann made this statement and he extended the discussion for general object, for a general object. For a general object, you will simply say that dq upon dt for a general object, general object is equals to emissivity E. Gurdunda, emissivity and ఏంటిరా? Power emitted by the object divided by power emitted by black body. ఇదే కదా? Yes. So A into dq upon dt for a perfectly black body. అంటే E into చెప్పండి dq by dt for a black body is sigma a t to the power 4. ఇదే కదా? Yes. So that is dq upon dt for a general body. కానీ there is a little understanding problem రా. Problem అంటే ఏంటి? ఎప్పుడైతే నేను చెప్పిన కదా, when you have the objects, here. What did I say? It will simply not emit, it will also absorb some రా. It will also absorb at any temperature. Does not matter. At any temperature, the heat is emitted the same time, absorbed also. Yes. అంటే we have to do some correction రా. ఇప్పుడు కరెక్షన్ గురించి చెప్పాలంటే try to visualize, okay? If you have the object, అందరికి ఇదే, if this is your object అంటే temperature of object, this is the temperature of surrounding. Due to the temperature difference, some radiation is flowing away, అంటే flowing out of the object. ఇదే కదా? Yes. So this is your radiation that is flowing out రా. కానీ at the same time it is receiving from the surrounding also. Understanding? Yes. Receiving from the surrounding also. చూసుకోండి. This is the received radiation రా. So for example, it had 100. Try to visualize. Okay, it had 100 rupees. 100 rupees ఉంటే he spent 80 rupees రా. He spent 80 and he received 20. How much did he spend? How much did he actually spend చెప్పండి. So total lost money is equals to spent minus received కదా. Yes, spent minus received రా. Spent in how much is spent రా? This అంటే object కదా. Yes sir, sigma e a temperature of object to the power 4 minus received రా. Received is same, చూసుకోండి, dq by dt received is equals to same sigma EA కానీ temperature of surrounding to the power. So you can simply say sigma EA temperature of surrounding to the power 4. And this is the net energy that is lost. Net power I would say, okay? So now you will simply say sir, dq upon dt net is equals to sigma EA temperature of object to the power 4 minus sigma EA temperature of surrounding to the power 4. Common తీసుకోండి రా, sigma EA common temperature of object to the power 4 minus temperature of surrounding to the power 4. ఇదే కదా. Yes. ఇప్పుడు చూడండి అందరికి, all of you try to understand, okay? I'm coming to a very important discussion. Now you have the object, ఇదే కదా. Yes, let us say the mass of object is m, specific heat of the object is C ra. Now the radiation is happening ante heat is getting lost kada. Yes, so sir, let us say the temperature initial is T1. After the radiation has been lost, temperature decreases. Enduku sir? Because heat is gone in the form of radiation. Heat is gone ante temperature decreases ra. T1 nunchi T2 it converted లేదా it decreased from T1 to T2. ఇదే కదా. What is heat రా? mc delta T గుర్తుందా? Heat that is received or heat lost. ఫార్ములా ఏంటి రా? టెంపరేచర్ ఇంక్రీజింగ్ ఆర్ డిక్రీజింగ్, స్టేట్ ఫిక్స్డ్, టెంపరేచర్ చేంజ్, mc delta T. అదే సార్ యువర్ mc చిన్న టెంపరేచర్ dt, ఇదే కదా. dt it is the small heat dq that is lost రా. చూసుకోండి, ఇదే కదా. yes, your small heat dq is this. అంటే సార్ mcdt t అంటే టెంపరేచర్ డివైడెడ్ బై d small t అంటే టైం రా. డోంట్ గెట్ కన్ఫ్యూజ్, ఓకే? షుడ్ బి ఈక్వల్స్ టు వాట్ కెన్ ఐ సే సార్? సిగ్మా e a టెంపరేచర్ ఆబ్జెక్ట్ టు ద పవర్ 4 టెంపరేచర్ సరౌండింగ్ టు ద పవర్ 4. ఇక్కడ నుంచి చేంజ్ ఇన్ టెంపరేచర్ విత్ రెస్పెక్ట్ టు టైం ఇస్ గివెన్ యాజ్ సిగ్మా e a డివైడెడ్ బై mc టెంపరేచర్ ఆఫ్ ఆబ్జెక్ట్ టు ద పవర్ 4 మైనస్ టెంపరేచర్ ఆఫ్ సరౌండింగ్ టు ద పవర్ 4. ఇదే కదా. Yes, try to visualize. Now this is a to the power 4 minus b to the power 4 ra. Ante t0 square whole square, t0 to the power 4 kada, t0 square whole square minus ts square whole square. Idigo. So you simply say sir, this I'm simplifying only this, okay? So focus only here ra. t0 square whole square minus ts square whole square. Sir, a square minus b square form. Visualizing. చెప్పోరా, a square minus b square is a plus b into a minus b. అంటే a plus b into a minus b. ఇదే కదా. ఇది కూడా సేమ్ ఫార్మ్, a square minus b square కదా. సో యూ రైట్ t0 square plus ts square multiplied by t0 minus ts into t0 plus ts. ఇదే కదా. yes, so ఈ అన్నిటిని you will be substituting in place of that. గుర్తుపెట్టుకోండి అందరికి. సో యూ సింప్లీ సే సార్, చేంజ్ ఇన్ టెంపరేచర్ విత్ రెస్పెక్ట్ టు టైమ్ ఇన్ సిగ్మా EA. Instead of this expression, write this. అంటే you will simply say sir, t0 square plus ts square అంటే object square plus surrounding square multiplied by temperature of object plus temperature of surrounding multiplied by temperature of object minus temperature of surrounding is given as the rate of change of temperature. If your temperature of object is roughly equal, not exactly equal, చూసుకోండి, roughly equal అంటే this term is there, exactly equal అంటే this becomes 0. ఇదే కదా. roughly equal అంటే it's a very small term, but there ఇదే కదా. yes, so when these terms are there, you can simply assume they are equal. They are not creating any problem kada. They are getting added to t plus t becomes 2t ra. Kani here it becomes t minus t 0. Kabatti I am writing they are almost same, unte these value you can ignore ante make them same for these two. Kani here you cannot make the same. And you will simply say that dt upon dt equals to sigma EA T naught square plus T naught square only, because almost same kada, yes, multiplied by T naught plus T naught only, because almost same kada, yes, multiplied by T naught minus TS. Hey, sir, are you gone mad, sir? Why are you not taking T naught minus T naught? They are not exactly equal, almost equal, bro. Almost. Okay, so you will simply say that sigma EA T naught square plus T naught square ante 2 T naught square multiplied by T naught plus T naught ante 2 T naught multiplied by temperature of object minus temperature of surrounding. You will simply say that 4 sigma EA T naught cube multiplied by T naught minus TS whole divided by MC kada. Here also it should be MC, I forgot that. I'm sorry, okay, MC. Here also it should be MC. Okay, yes, MC. చూసుకోండి ఈ మొత్తం క్వాంటిటీ రైట్ ద కాన్స్టెంట్ క్వాంటిటీ కదా your dt upon dt రా ఇదిగో so your dt upon dt is directly proportional to the change in the temperature of your object and surrounding. ఈ ఫార్ములా అంటే న్యూటన్స్ లాస్ ఆఫ్ కూలింగ్ we have directly learned that. What is it రా? It is చెప్పండి అందరికి ఈ మొత్తం అంటే this is known as Newton's laws of cooling. Yes, it is known as Newton's law of cooling. అంటే ఏంటిరా? The rate of change of temperature difference లేదా the rate of change of decrease in the temperature is directly proportional to the difference of the temperature from the system and the surrounding. ఇదే కదా? Yes. So Newton's law of cooling has been completed. Andariki. Did you understand? Edina doubts unte cheppandi. Okay, this was all about your Newton's law of cooling. Okay, right. Ippudu, how are the questions coming, Ray? Chuskondi. There are two methods. To be honest, there are two methods unnai. Kani for you, the second method is not there. Okay, or you can skip the second method or ignore the second method. We'll only consider on the first method. First method and the we go with the average temperature. We talk about the average temperature only. The question will be given. The temperature of the body decreases from 50 degrees Celsius to 45 degrees Celsius in 5 minutes. Find how much time it will require to drop the same temperature from 45 to 40 degrees Celsius. Something like this. Okay? Yes. Sorry. So when you are given with the average temperature, how will you deal it? Possible. Let us take one question, Randariki. Okay. Average temperature is the method. Okay, method. Average temperature method. Okay, let us take a question. This question is very important. Andariki, try to visualize. Okay, it's a very, very, very important question that has been asked. The temperature of an object decreases from 40 degrees Celsius to these questions kada. Yes, so you'll simply say ఈ కేసులో your dt, okay, dt upon dt ra, temperature and time is equals to some constant ra, k multiplied by t dash minus t. ఇదిగో you understanding? Your dt upon dt is equals to some constant. ఇదే కదా. There is one more information that I need. Temperature of surrounding. ఇదే కదా. Should I see? Temperature of surrounding, let us take it as 15 degrees Celsius. Let us go with this. చెప్పండి. So ఈ ఫార్ములాలో it should be temperature of object minus surrounding కదా. But what temperature will you take here ra? What temperature will you take? చూసుకోండి, it was 40 also, 30 also. What temperature will you take? Take average. So dt అంటే ఏంటి రా? T2, temperature 2 minus temperature 1 upon time should be equals to K into average temperature minus temperature of surrounding. ఇదే కదా. Yes, for the first condition ra. For first condition. For second condition, same equation. T2 minus T1 divided by T should be equals to K into T average minus temperature of surrounding. Same equation. Just divide them. When you're dividing, AK gone. Ardhamaindi? Yes. So tell me that in the first case, your temperature T2 was 40. T1 was 30. Ide kada? Substitute cheskondi okasari. You will simply get, sir, 40 minus 30 divided by how much time ra? Time taken is 10 minutes. Divided by another case. Cheppandi. Another case is 30 minus 20 kada? Yes. So 30 minus 20 upon T. I don't know. Naku T kavali ra. Here. Ade. Should be equals to temperature average. For your first case, the average temperature is 35. Minus temperature of surrounding is 15. Divided by, మీ సెకండ్ కోసం చెప్పండి ఒకసారి, your average temperature is 25 minus 15. ఇదే కదా. 35 minus 15 is 20. This is 10. 20 by 10 అంటే 2 రా. And here 40 minus 30 is 10 by 10 divided by 10 by t. ఇదిగో 10 by 10 is 1. So that means 1 upon 10 upon t అంటే t by 10. Sir, t by 10 should be equals to 2 అంటే t is equals to 20 minutes. Visualize. Okay. This is how you do it. And దాని తర్వాత one last topic that's remaining is your Wien's displacement curve. So the scientist, Wien, what he did, he took an object radiating emitting the radiations. So he plotted a graph of what, sir? Wavelength అంటే ఏంటి? Radiation అంటే EM wave. EM wave కోసం you have wavelength కదా. Yes, he plotted the graph of your wavelength versus your intensity. ఇదిగో your wavelength versus your intensity. Your wavelength versus your intensity. And he found that the graph was coming different for different temperatures. చూసుకోండి, T temperature కోసం the graph was like this. If you increase the temperature, the graph was coming shifted forward and this is the maximum intensity kada. Maximum intensity అంటే lambda maximum అంటే ఈ wavelength కోసం your intensity is maximum. Let us say lambda m1 ra. And here in this graph అంటే your second temperature T2 కోసం this is the wavelength for which you have the second maximum intensity. Temperature T1, temperature T2. What did he say, sir? If your temperature is more, less. In case no, your T2 should be greater than T1, kada? Yes. So if your temperature is less, your lambda m is more. And if your temperature is more, your lambda m is less. Ante entira? That means you simply say that your lambda m is inversely proportional to temperature. Ante your lambda m into temperature is equals to constant V. Ee constant ante V is constant ra. Idigo. Sufficient. More than sufficient. Okay. ఏదైనా డౌట్ ఉంటే చెప్పండి. సరే. So with that, we will simply say that your chapter thermal properties has been completed. Although we only took more theory and it's required for problem solving also. Okay. So ఏదైనా డౌట్ ఉంటే చెప్పండి, or else can we stop this session? Okay. Done. So if you don't have any doubts, all of you, we may wind up with this session, right? Yes. So good evening, bye-bye everybody. We don't have the lecture tomorrow, but on 1st of February, we have a 12 hours marathon run. We'll be discussing about your modern physics, okay? Modern physics. So modern physics, it will be right from the beginning of the chapter till the end of the chapters along with your practice tests, okay? Each practice test will have somewhere around 15 questions around, okay? Mock tests. Sorry. So we have introduced this, Ra. Good. Good night, everybody. Bye. You know, today's class was a little hectic, Ra. Some idiot smashed into the chat box. But it's all right. Some days are happy, some days are sad, some days are angry. Okay? Sorry. Good night, everybody. Bye.